had already a very fruitful day, and we'll continue today again with a whole series of most attractive plenaries, GNFs, technical sessions, so I hope you will take the maximum out of all of this. Let me remind you, and you all have already used our app yesterday very intensively to ask questions through the Slido system, and you have seen that the moderators are more than pleased to have these kind of questions in order to engage the audience also from here and from remote. So please continue doing that. But before I proceed now, I would like to introduce the first part of today's program, and that is a highlight lecture. And this highlight lecture is tackling the important and challenging topic of how Earth observation can contribute to climate change adaptation strategies and play a key role in increasing climate resilience for communities worldwide. And to deliver this highlight lecture, it is my great pleasure to introduce Dr. Richard Spinrad, Undersecretary of Commerce for Oceans and Atmosphere, and also Administrator of the US National Oceanic and Atmospheric Administration, NOAA. The highlight lecture is titled, and you see it up here, Earth Observation for Building Climate-Ready Society. NOAA is, of course, one of our most distinguished members, and I would like to thank Mr. Spinrad and NOAA for the permanent support you are giving to the IAF. Let me introduce Dr. Spinrad to you. In his role, he is responsible for the strategic direction and oversight of NOAA and its more than 12,000 employees. This includes developing NOAA's portfolio of products and services that are integral to addressing the climate crisis and building a climate-ready nation, enhancing environmental sustainability and fostering economic development and centering equity in NOAA's service delivery and internal operations. Dr. Spinrad has had an illustrious career to date, including previous tours of duty at NOAA, where he led NOAA's Office of Oceanic and Atmospheric Research and the National Ocean Service, and served as NOAA's Chief Scientist from 2014 to 2016. He has earned numerous honors and awards for his work, including 2 Presidential Rank Awards. Dr. Spinrad, it is my pleasure to call you up on stage. The floor is yours.
Thank you so much. It is truly an honor to keynote this morning and talk about what I know is going to be a very relevant set of topics, and one which I would like to think brings to bear so much of the technical information we are sharing here at GLOC. I'll start by making a very simple statement. The wolf is in the house. The wolf is no longer at the door. The wolf is not out in the field. The wolf, which is climate change, is in our house. We are all feeling it right now. This is no longer a theoretical consideration for our children and our grandchildren. Let me ask the audience a couple of questions. How many of you own condominiums in Maui? Yeah, I didn't think so. How many of you live in the interior in Alaska? I didn't think so. How many of you buy insurance? I thought so. Now let's make it easier. Show of hands. How many of you like to eat? If your hand is not up, please ask your neighbor to help you out. Every one of those questions is tied to issues associated with climate change. We're feeling the impacts. We're feeling the effects in terms of the economy. We're feeling the effects in terms of health. We're feeling the effects in terms of food security, water security, energy security. So everything we're talking about here at this conference has direct and immediate relevance, not just to the people in this room, to any person on the street, anywhere in the world. It's my goal here in the next few minutes to share with you some perspectives about how the work that is done, especially in the framework of remote sensing, directly impacts our ability to make decisions. Decisions at the level of the individual, decisions at the level of government, decision makers and policy makers, decisions at the level of industry, tied to any number of threats which are depicted in this particular slide. We tend to get a little bit biblical when we talk about climate change. We talk about floods, fires, coastal inundation, heat health. But these are the things that are affecting all of the securities that I talked about a minute ago. So what are we doing about it? What are the things that we, as technologists, scientists, engineers, policymakers, need to do to help ourselves get to what in the US we are calling a climate-ready nation? And I would argue that that's all part of a climate-ready society and a climate-ready globe. Our ability to have accurate, reliable data, translate that into information, translate that into knowledge, and translate that into intelligence is what is at the heart of what we are trying to do here. So think of this as a flowchart, if you will. I don't expect you to be able to read every detail of this slide. It violates every principle of PowerPoint slideology, but I will tell you it brings an important point to mind. And that is that in order to be a climate-ready nation, we need this full spectrum of expertise and capabilities, going from the fundamental understanding of how to make observations, what to make observations of, when and where to make those observations, then taking those observations, those data, translating them through research and development into product lines that meet the needs of communities. And oh, by the way, an important aspect of this is co-development. So that on the far left of this curve, you're actually talking with the individuals, the institutions that need to solve problems. Then building those capabilities, enhancing capacity for communities, for geographies, for different sectors like the emergency management sector, and transmitting that intelligence, that environmental intelligence, into the hands of people who can make decisions. Evacuate, don't evacuate. Invest, don't invest. Store water, don't store water. Make those decisions, make those applications, and then evaluate. How well did we do? Did we solve the problem? Did we improve the ability to pre-position and mobilize in the threat of some emergency? And then start the whole cycle again. This is at the heart of what an agency like the U.S. National Oceanic and Atmospheric Administration is all about. I can point to this slide and I can say, this particular capacity for making observations, this particular capacity for translating and transmitting and conveying and disseminating information resides in this part of the organization. But wait, there's more, because you need to frame this around the value chain that is specific for fire, for drought, for flood, for heat, for coastal inundation, for marine resources. At NOAA, we also operate the National Marine Fisheries Service in the United States. So we need to be able to take this information and be able to tell the fishing community in Alaska that 20 years from now, you're going to be catching more Pacific cod than salmon. You better start thinking about how to structure your industry around a fundamental ecosystem change. We also have to consider the scales. So it's one thing to deal in IPCC, global stocktaking direction, and talk about national level observations to support reaching nationally determined contributions to carbon dioxide reduction. It's another to turn to the local community in a small town in Florida and say, we can provide you a tailored sea level rise product that you can use to make decisions about building a seawall in the next 10 or 15 years. So this whole value chain really captures what a climate-ready nation is all about. At NOAA, we have a couple of other priorities we build into this. Obviously, establishing that role as the authoritative source for operational climate products and services is critical, in much the same way that having authoritative sources for things like navigational charts is critical. You don't want to go shopping for who can sell you the cheapest navigational chart. You want the most authoritative navigational chart. Similarly, climate products and services. You want to know that what you're getting is authoritative, reliable, accessible. We also want to do this in a sense of balance. And this is where many of the issues that we are doing in terms of being good stewards of the environment at NOAA, but also part of the United States Department of Commerce, mean that we should be looking at how we can build out economic opportunities. And I share with you, by one way of example, that in the 2 years I've been on this job, I've met with about 150 startup companies working in the climate enterprise, what I call the climate industrial complex. How can we do our job in observations in that full spectrum I just shared with you, and at the same time make sure we're supporting entrepreneurs, investors, venture capitalists to build out new capabilities? And this third pillar I can't overemphasize, and that is the one of equity. When we put out products like urban heat predictions, are we really being equitable? In a city like Chicago, we can see as much as 5 to 10 degrees centigrade difference in a developed community versus an underserved community in the heat that they will face. That has enormous consequences in terms of health impacts. So our role to exhibit equity in how we build and provide services means making sure that all communities, unserved, underserved, have a voice at the table, not just at the end of the process, but up front, telling us what is needed, when is it needed, how can it be delivered. The assumption of dissemination, in many communities, they have no access to standard internet connectivity. How do we make sure those communities can get the products? It's no good in that value chain if you get all the way to the stage of the dissemination and you cannot get that environmental intelligence into the hand of an underserved community. So let's get into the actual nuts and bolts. At NOAA, we have this enormous portfolio of capital assets that we use to make the measurements on land, at sea, in situ, remotely. And what you're seeing here is just one sense. We like to say at NOAA that we make observations from the surface of the sun to the bottom of the ocean. And in doing that, it means measuring not just the traditional physical parameters, if you will, sea surface temperature, atmospheric chemistry, but also having responsibilities for tsunami detection out at sea. Also having responsibilities for measuring the health and distribution of corals, not just around US waters, but around the world. We provide the navigational charts in the United States exclusive economic zone. And of course, I'll say a lot more about the middle slide and the bottom right slide in terms of our remote sensing capability. We have a Navy, we have an Air Force, we operate 17 satellites, 16 ships, 9 aircraft, and we do all of that to supply the environmental data and information that I've just alluded to. I'll talk a little bit more about our GOES-R series, about our LEO series, as well as some of our space weather observations. And in fact, we're very proud of the fact that just last year we enjoyed 2 launches and 2 classes of our satellites, the geostationary satellites, GOES-T launch, which became GOES-18, which is now our West Coast geostationary satellite. It observes many of the Pacific hurricanes. It observes the atmospheric rivers that we've heard so much about hitting California this year. And then, of course, in our low Earth orbit, we have the JPSS-2 launch, which was in November, shown here as well. That's now the NOAA 21 satellite. I'll say a little bit more about the specifics on that. The GOES-18, as it's now called, GOES-T, shown here at launch, went operational about a year ago. NOAA 21 will be operational later this year. These satellites are providing us extraordinary capabilities, sounding and imaging. On the left, you see the GOES-18 image showing some of the atmospheric activity. We have the advanced baseline imager. We have the geostationary lightning mapper. We also have solar observations on the GOES satellite. And on the right, you see the JPSS-2, again now called NOAA 21. And this includes a whole range of cross-track infrared sounders, sounder. It includes the ozone mapper. It includes the advanced technology microwave sounder, as well as the visible and infrared imaging radiometer suite. So you can see that we're starting to get extraordinary quality, extraordinary resolution, and all of this is fine, but unless we can start demonstrating what this is doing for us, it's nothing more than pretty pictures. And so I can tell you that using these kinds of capabilities and quantitative approaches to Earth observation, we've been able to dramatically improve things like our hurricane track and intensity forecast. Track forecast, we've improved probably about 20 or 25% in the last 20 years, largely due to remote sensing capabilities, but also due to some of our airborne aircraft capabilities. Intensity, we've also made improvements, not quite as much, but that's where some of the new capabilities for observing things like total ocean heat content are really going to help us make these dramatic improvements. We're very excited about the current capabilities for doing a whole range of things. I'll show you some specific products and get back to this value add concept in just a moment. But I wanted you to get a general sense of the current set of capabilities. What's in front of us in terms of capabilities in the future. Advancing some of these capabilities on low Earth orbit, our near Earth orbit network, or NEON, is going to look at things like hyperspectral infrared soundings, radio occultation soundings, working more closely with the private sector in terms of incorporating capability. But I'm particularly excited about some of the things that you see here with respect to both our GEO and LEO capabilities, enhancements in visible infrared, nighttime visible, enhancements in lightning mapping. I'm an oceanographer. I did a lot of my early work on, I'm going to date myself now, the Coastal Zone Color Scanner. Anybody remember the Coastal Zone Color Scanner, CZCS? Man, we've really come a long ways in terms of ocean color, both in terms of spatial resolution, but also spectral. And now we're able to do things with respect to looking at the health of coral reefs, with respect to looking at pollution, with respect to looking at and predicting harmful algal blooms. 10, 15 years ago, I could not have talked to you about having an operational harmful algal bloom product. We now do that in both freshwater and saltwater, largely due to some of these kinds of capabilities. And of course, when we start talking about IPCC requirements, nationally determined contributions, atmospheric composition is a capability we are particularly excited about. So let's talk about some of these products. Let's look at a sea surface temperature anomaly product here in the equatorial Pacific. I hope this audience realizes that this kind of image is one that you are going to really be seeing a lot of in the months to come. We are in a situation right now where there is a relatively high probability, above 60%, maybe even higher, of a significant El Nino in the next 6 to 12 months. So we're going to start seeing some very significant deviations from average temperature in some of these images. We also use this, as I said, for looking at coral reef ecosystems. One of the best indicators of potential for bleaching of a coral reef is the sea surface temperature. We can get ahead of the coral bleaching phenomenon by providing forecasts that are based on patterns and magnitude of sea surface warming that we're seeing here. A lot of this kind of information is also critical to fisheries. So when you start looking at these kinds of patterns and look at critical places, critical habitats like the North Pacific, where a lot of salmon reproduce, we can start making seasonal and even longer projections of relatively how many salmon we're going to see in the fishery off Alaska. And then some of these kinds of observations also contribute to our capability to do things like tsunami forecasting as well, giving us a better characterization of sea surface conditions, patterns, currents. But you get a sense of the diversity of products that we can develop using this kind of image. I want to show you another image that is specific to our wildfire tracking capability. And I bring this one up because before I took this job, I was living in the state of Oregon, which is in the top center of this slide. This particular image was taken in September of 2020, set of images, this video, and I happen to live, I'll try to time my talk here. You see those three fires in the middle of the state there? I lived about 5 miles from the one that is to the south. Fortunately, I had colleagues at NOAA. I was not with NOAA at that point. I owned some land that had highly flammable plants and trees and shrubs on it. Using this information, I actually made a decision that I needed to clear my property of that flammable material. It's a very personal application for me of some remote sensing imaging. And this is only going to become even more critical. We used to talk about fire season in the United States. We don't talk about fire season anymore. It's a year-round phenomenon. We're seeing these kinds of things happen in the dead of winter, and similar for many other phenomena. But you also see that this kind of information is going to be extremely useful for emergency responders, local firefighters. Our ability to track lightning as well as an indicator of where there's a higher probability that fires will start is enormously valuable. And then look at these images and realize that some of the trajectories, the smoke, and the dust that's emanating from these fires is also useful for the health community to make decisions about where we might see decreased air quality in a particular area. You can follow flow patterns there. A lot of this information was used, in fact, 3 years ago to warn people on the East Coast that they were going to start seeing some of the smoke impacts of these West Coast fires. These kind of fires and this kind of tracking also gives us an ability to understand where there will be burn scars. So once the fire is out, there's a problem with respect to how the terrain has changed. And then when you complicate that by extensive rains, don't forget, when you look at California, this is a state where just 2 years later, we started seeing these extraordinary atmospheric rivers. I guarantee you that the burned areas shown from this image were subject to extreme flooding. We call that cascading risks. So we went from having the extensive fires in 2020 to the heavy rains in subsequent years to increased flooding, where we might not have had it had there not been these burns. I talked a little bit about hurricanes. This is an image from Hurricane Ian a couple of years ago, where we now have resolution and cadence of imagery such that we can dramatically improve our forecasts of where the hurricane is going to hit and what the intensity of the hurricane will be. Now, this one is particularly important in the context of climate change, because if there is one thing we know, it is that the nature, the dynamics, the magnitude of these storms is changing. Many of you may have seen we are right now bracing for a severe typhoon to hit Guam. It will hit Guam later today. We know that from this kind of imagery. We know that many of the storms, Hurricane Harvey dropped more than 1.5 meters of rain. We didn't measure rain in meters when I was a kid. We're starting to see some extraordinary changes. What do we do with this information? It's not good enough to take an image like this one and hand it to a decision maker. It's cool, it looks great, they don't know what to do. So one of the really important things for us is to develop tools like this, and we work extensively with our colleagues at Esri to develop this, which we call the Climate Mapping for Resilience and Adaptation camera product. And basically it takes all that cool data, information, intelligence, and translates it to decision aids, where people go to a portal, in this case climate.gov, and can go to their area, anywhere in the United States, and determine what's my risk of flooding, of fire, or of any of these other issues. What exactly constitutes a climate-based or a climate-driven flooding event? What's my probability? Also, what are the sociological issues with respect to underserved communities in this area? Who's going to get hit hardest? And then start making decisions about what to do. So as you can see on the top, it gives you everything from the data, if you're into that, to some of the policy issues, to some of the tools that you can use to make decisions about preparing for these particular risks. Right now, what I've just shared with you is done not just by us. This is a snapshot of the constellation of our geostationary, near-polar, and deep space. I haven't said much about space weather capabilities, but this next slide is really the kicker for this audience. This is where it happens. This is where the power of the remote sensing capability really bears fruit, and that is in the partnerships that we have. You can see just by how much we've populated the constellations and increased the coverage, the resolution, the diversity of measurements made. Obviously, we've got a little piece there that says commercial data purchase. This is a brave new world here too. I've had any number of conversations just in the last 24 hours on that. And I would say one of the interesting things about this is how IAF is working with groups like the Group on Earth Observations, GEO. So I am the US representative to GEO, and I'm particularly excited about the potential of how IAF, getting into this climate space, can work with GEO to talk about what do the products of the future look like. Products tied to global drought, products tied to heat health. So it's an exciting opportunity now for using the capabilities so well represented here at IAF to work with the international community. Last point is that I cannot drive home strongly enough with this audience that it's not good enough to just simply have the high quality, easily accessible data. At the end of the day, we have to be able to support decision making at all levels. And this slide calls out everything from emergency managers to policy makers to industry like insurance companies. And just to put a fine point on it, I show you on the slide on the lower right. 40 years ago in the United States, we would typically have $3 billion disasters every year. Right now, last year we had 18. The time between billion-dollar disasters, and that's inflation-adjusted, yes, in case you were wondering, the time between billion-dollar disasters has gone from roughly 3 to 4 months to more like 3 weeks. So we had better get in front of this problem, and you all are part of this solution. If I've done anything in these last 20 minutes, it's hopefully convinced to you, one, how we will use the information you are developing, and two, why it is so important to ensure we not only have a climate-ready nation, we have a climate-ready globe. Thank you very much.
Thank you so much, Dr. Spinrad. I think you will agree with me. This was one of the most exciting presentations of this topic I've ever heard. Thank you very much, and we look forward to working together with you and with NOAA. And with all your colleagues. Thanks very much for your engagement with IAF and for the exciting presentation.
Thank you very much.
I hear we have some questions. Yes.
I thought you were giving me the hook.
No. Please, go ahead. Is
the mic on? How does the work of NOAA relate to the initiatives and projects of private EO companies?
I love that question. Intimately is the short answer. NOAA, as I've said, and I'll repeat, we sit within the Department of Commerce. So part of our mission is economic development. And I think more specifically what we're doing right now is trying to define, I call it the swim lanes, the responsibilities of the public sector and the private sector. How can we at NOAA, in ways similar to what we've done with commercial weather, try to define where our responsibilities lie to provide the fundamental data upon which we can either complement with commercial data buys or we can facilitate development of commercial value-added products and services. So it's a very active dialogue. We've held a number of industry roundtables. We have an active set of discussions with the commercial remote sensing industry. I've had a couple of meetings here. But I would say we're not doing enough. There's a lot more we can do. So I actually welcome your thoughts on how we might do better in terms of those kinds of discussions. Thank you.
One more. Climate ready still sounds like preparing in advance of an event rather than systemic changes to chronic changes. How do we move beyond the disaster event?
I like that question. I would argue that I am health ready I may not be in the best shape that I've ever been in my life, but I know I'm doing the things to make sure I can live a healthy life. To me, that's prosperous, that's benefiting. There's a tenor to the question that suggests climate ready might be sort of getting into a defensive crouch. If you look at the way we've characterized this concept of climate ready, there are two words in it that are specific and unique, and they are the words benefit and prosper. I consider myself a climate realist and therefore a climate optimist. And I actually believe with all of this cool stuff that we've been talking about here, we can position ourselves so we are climate ready in the sense that we can prosper. We can figure out how to fish differently, how to engage in agriculture differently, how our economic structures and financial structures need to change. So to me, climate ready is actually pre-positioning for the changes to benefit and prosper. And I think it's realistic, but it really depends on developing a lot of new capabilities, which we don't have in hand right now. Thank you.
Once again, thank you very much, and pleased to have you here. So now, let's jump right into our plenary program. The first plenary of today will focus on the title From Earth Observation Data to Successful Climate Policy, the role of the space industry. And I'm very pleased to welcome on stage the moderator of this session, Ms. Charlotte Bishop, Senior Project Manager at KSAT. We just need to set up our tables. Yes, please. Welcome. And thanks for moderating this session.
Thank you. Thank you very much, everyone, and welcome to this panel discussion, which has already been well introduced. It's my pleasure to be invited to be moderator of this session, and as the speaker has just introduced me, I'm from KSAT, I'm a project manager, but I also am the program lead for the NICFI Satellite Data Program, which many of you have heard mentioned, alluded to by the Minister yesterday and throughout some of the discussions. Before I introduce the panelists, I just want to take the opportunity to set the scene a little bit ahead of the start of this discussion this morning. So we are seeing that satellite technology is becoming increasingly important in the forefront of government's agenda when it comes to climate mitigation, whether that be the fight against tropical forest deforestation or monitoring and reducing global emissions. At the same time, satellite technology is also responding and moving towards an alignment to be that more beneficial solution in support of climate policy agenda, and where more and more the understanding and knowledge gathered from complementary solutions, including satellite imagery, can help improve decision-making, planning, and de-risking activities. But that is not to say that there is not a lot more work still to be done. It is not a question of satellites replacing traditional methods of monitoring, but that the information collected from a range of sources provides a greater understanding, context, and importantly, a different perspective. One way in which this has been achieved with success is through public-private partnerships. These allow us collectively to facilitate, assess the opportunities to leverage such data, where that has historically had many more barriers to access. These initiatives are the basis for further discussions on how the EO industry, as well as the public sector, can work together collaboratively for a common goal. This panel will touch on some examples of these types of programs, like the NICFI Satellite Data Program, and how these initiatives are identifying opportunities and potential gaps to be considered for future climate policy. I will be joined by a panel of 5 speakers today, and it's my pleasure to begin introducing them. So firstly, please welcome Rolf Skatterbo from KSAT. Rolf is a co-founder, president, and CEO of Kongsberg Satellite Services, or KSAT. And KSAT is an Earth observation satellite data provider and leading ground station provider. The mission of KSAT is connecting space to Earth. So a big part of what we do is actually helping get that satellite data down from those satellites and being able to distribute that to the satellite operators and, importantly, to the users who make benefit from those satellite missions. Next, I would like to introduce Dr. Julian Fox. Julian Fox is a team leader of the National Forest Monitoring, MRV and Platforms at the UN Food and Agriculture Organization. He now leads a team of technical specialists at the FAO focused on capacity building for forest countries, focused on peatlands, restoration and measurement, reporting and verification. Welcome. Next, I would like to introduce Diveka Rogan. Diveka is the Deputy Director of Norway's International Climate and Forest Initiative, or NICFI, at the Ministry of Climate and Environment. And NICFI, as you have heard, is the flagship international climate and nature initiative working to halt and reverse tropical forest deforestation. Next, I would like to welcome Niels Wielod to the stage. Niels is from Satelligence, founder and co-director. He's determined to make a meaningful impact, measuring progress with satellite-based analytics, with a focus on more sustainable agri-commodities, and has been working in commodity production in these landscapes for over 20 years. Welcome. And last, but by no means least, please welcome Will Marshall. Will is the chairman, co-founder, and CEO of commercial satellite operator Planet, a scientist turned entrepreneur who has helped build Planet from a small team in a garage to the company of nearly 1,000 employees that it is today. The mission of Planet is to accelerate humanity towards a more sustainable and secure world, something that through the high cadence and always-on capability of the satellites that they offer continues to drive towards and support across different environmental applications. So welcome to you all. So I'm going to start this panel with a question to each of you in turn, and then I hope to open that up to a much wider discussion. I will start with you, Rolf, if I may. Perhaps you can give some examples of where you see public and private sectors working together in the Earth observation industry.
Thank you, Charlotte. I'd like to do that. And as you already did say in your introduction, we're in the fortunate position of connecting space and Earth, making sure that all the data that's flown up there are taken down so it can be actually put into actionable information that can be used here on Earth. So we're communicating with satellites more than 1 to 1.3 million times every year. That shows two things. It shows a lot of satellites, a lot of information is gathering, and it's gathered, and it's also quite efficient way of getting it down into Earth. But to your question, I think the public and private cooperation is a very interesting and good one, and that's not a controversial thing to say in this audience. But they both strengthen and enhance one another. Because at one point, and no offense to anyone, the private side tends sometimes to be a little bit more innovative than the public sector. So that means that the private sector can come up with ideas that the public can endorse and support in the initial phase. Having said so, the public sector can also put constraints and challenge the private sector to become innovative and be creative in their way of thinking. So that relationship strengthens both parties, and it can definitely be used in the future. As a final short example, I had a chat with our friends from UMETSAT yesterday, and they are doing satellite collection in the meteorology world through traditional systems where they have big legacy satellites coming down into the Earth. They have a standard set of collecting data. We're having a really good dialogue these days on how we could use innovative new approaches to satellite data collection and how that can be ingested into their systems. So by talking together in the pre-phase, it's up to them to decide how they do it in the long run. And as the previous speakers say, come up with solutions where you have both legacy systems and new systems working together. So long answer to yes, I see a lot of potential in that relationship.
No, thank you, Rolf, and I think that leads on to the question I just want to ask Will, and that's why are these commercial missions so important for public climate benefits?
Well, I think it's a little bit to do with what Ralph was just saying about the fact that there's this innovation, it produces new data sets. I mean, really what we're finding in the beginning, there's a space renaissance going on, everyone knows about the cheaper rockets, but actually, the big upshot is less about the rockets and the satellites, which we space geeks really love, but more about the data and the applications to the Earth, right? I mean, it's all connected with the Earth economy, whether that's Starlink or OneWeb producing more communications, data bandwidth, or Earth observation fleets like our own, or a couple of hundred satellites that produce more data. We're producing gobs more data or moving gobs more data around the planet. The upshot of which is helping us to take care of the planet. You can't manage what you don't measure, right? I'll give you a couple of examples of this. One is that we've been working with NASA on getting our data to underpin key climate variables. And it turns out the extra resolution compared with Landsat or Sentinel and the temporal resolution, when it's calibrated to those fantastic scientific missions, is more useful for a whole bunch of measurement of climate biodiversity, glacial modeling and everything. And so we're seeing thousands and thousands of papers come up because of this innovative program we have with NASA. Another one is our partnership with Rolf and Norway and the UN FAO here, our partners here on stage, which the Environment Minister mentioned yesterday, which is tracking deforestation in 64 countries. It's a public-private partnership where it's making some of that data available as a digital public good to track and stop deforestation in the 64 tropical belt countries, the lungs of our planet. And we're seeing a tenfold increase in the number of actions, that is, where interventions where the government, local police, can stop illegal deforestation, or courts of law can bring deforestation cases to court. And that is what is enabling, us to take care of our forests. So you can't manage what you don't measure, and private data sets are part of that puzzle.
Thank you, Will. No, and I think, and I'm sure we'll touch upon it in these discussions more, and the uniqueness of the satellite data program that Norway has funded and what that's now enabling. And I think there'll be some examples, I think, of how this data is being used as well. And Deveka, maybe this is a good time to move to you and move to perhaps some of these examples. And we heard from the Minister yesterday and through some of the other discussions about how, I think it's fair to say it's considered NICFI are showing some leadership in terms of the initiative taken here with the NICFI satellite data program. And I'm interested to hear your thoughts on why these types of partnership is so important for those policy goals that you have from Norway and beyond.
Thank you, Charles. And some in the audience might not be that familiar with Norway's International Climate and Forest Initiative, NICFI. So I'll just say a little bit about who we are and what we do. NICFI was launched by the Norwegian government 15 years ago, and it's Norway's largest international effort to help combat climate change and preserve biodiversity. Our objective is to support tropical forest countries with protecting what's left of the world's rainforests. Without these forests, there is no way that we'll be able to limit global warming to 1.5 degrees. There is no way that we'll be able to reach our global biodiversity goals. So improved monitoring of the tropical forests is really crucial if we are to reduce deforestation. We need to know what's happening in the forest, where the forest is disappearing, when it is disappearing, and why it is disappearing. As Will said, you can't measure what you can't manage, so we need this type of data. This type of forest monitoring is quite difficult, and satellite data, although it was available prior to the NICFI satellite data program, it was expensive, and it was only available to a few selected actors. So this is why NICFI decided to grant this free access to high-resolution satellite imagery of the tropics to anyone, anywhere. We felt this was really the missing piece in the global effort to protect the rainforests. And we got this great team together to help us with this. Kongsberg Satellite Services, Planet, and Airbus. Together, they ensure this regular distribution of satellite data and also help users with all kinds of technical issues. And I here also want to recognize FAO with the analytical platform CEPAL. I think without CEPAL, many out there would have access to the data, but not really have the resources to use it and to run the analytics. So since the launch of this program, which is now 2.5 years in, we've seen more than 18,000 registered users from 158 countries around the world. And we know that many, many more are accessing and using the data through the Global Forest Watch platform and the Google Earth engine. And I think it's a really powerful example of how public actors and private actors can join hands to find solutions, to give access to the data, to help users analyzing the data as a way of contributing to address the climate and nature crisis.
Yeah, no, thank you. And I'm sure we're going to talk a bit more about some of those outcomes as well and some of the things that we're seeing. But if I maybe move to you, Niels, coming from the kind of private sector side and how you're using this data, and maybe you can kind of comment a little bit from your experience on how now we're seeing that the private sector need to meet these obligations for climate-related policies more, the new EU directive, for example. How are you seeing that commercial services support and perhaps some of these other initiatives are able to help you meet those goals?
Yes, thank you. I think that the private sector speed, the passion and pragmatism has already been leveraged to make a difference. 17 years ago, I was at the climate conference in Nairobi, and then I met peatland specialists, scientists, renowned scientists. Peatlands store a lot of carbon in the ground. If they're deforested or burned, and they emit a huge amount of carbon. So they gave me their spatial data of peatland distribution. And at that time, I was working on spot vegetation, a time series of deforestation. That's 1 kilometer resolution. Every 10 days, you had a cloudy image. Yes, Will, that's 1 kilometer. You can imagine that now. That was before your breakthrough, before free Landsat, before the Sentinels. Anyway, I was at the poolside with my laptop, having a nice, cool Tusker beer, just overlaying this data of peatland distribution and of the deforestation and the plantations. And then we uncovered that actually the deforestation of peatland was 5 times as much as a normal forest, and that it was accelerating. So we wrote a quick note to the Dutch delegation. They took it to the agenda, and ever since it has been on the agenda of the climate conference to take action for peatland deforestation. And the second last example is that to help corporations prove no deforestation when they are sourcing on investing in ingredients or parts. For example, BMW, the leather in their cars, the timber in the furniture of IKEA, or the soy, cocoa, and palm oil for corporations just like Cargill, Unilever, Mondelez, PepsiCo, all the foods we eat, right? So we found that satellite data can be used to measure progress. We found that palm oil-driven deforestation is now at a 20-year low because all these companies have commitments. And that is really great news. Even the most aggressive campaigning NGOs applaud this progress. However, my final remark, I also want to say that there are still many more companies that we need to address. There are so many more users, and they don't have monitoring, they don't take action. And that is also because I think most of us are still living in parallel universes. We're all living in silos, and silos hamper progress. I think that if we work together, that spending, for example, millions in data and software. It's good, but it's not enough. In our work, it evolves a lot around the hand-holding of new users, educating the market. Many of them drown in data, so we have to help them. And unfortunately, not always the donor silo has been supportive of this kind of help. For example, the Joint Research Center in the EU, they are setting up a similar system with taxpayers' money. I think, why? Then also we hear some governments say, yeah, we cannot fund the private sector, that's for profit. So then they fund NGOs to do similar things. Why is that? I think that, yeah, philanthropy will not save the world fast enough. So it's also like the durable business models can help to educate the market, powerful, durable. Let us cooperate, let us work together, yeah, and to break down these silos.
Yeah, I completely agree with you, and I think we've seen that in the discussions from the first day here yesterday as well, about the power of working together and how beneficial that can be, and hopefully we'll touch on some of that during the discussion. And before we move to the discussion, Julian, I'd really like to, from your perspective, from UN, FAO, and the experience that you have, the adoption of this type of technology to support the monitoring and reporting is clearly critical to the work that you do from the UN side. Could you speak perhaps to how you are supporting countries in using this type of data and with their reporting obligations?
Sure, thanks, Charlotte. Yeah, and just, great intervention so far. So. Yeah, I think for me and for the forest monitoring community, the NICFI satellite data program was a real game changer. Actually, in 2018, as FAO, we were supporting many forest countries, and we identified a need for this sort of data. We have access to very high-resolution imagery through platforms like Google Earth, but it doesn't have a timestamp, right? And when countries are measuring, reporting, and verifying their data, they need to know exactly when the image is taken in a consistent way for reference level construction and then for reporting against that construction. So in 2018, we actually launched our own procurement to find sort of data that was high spatial, high temporal resolution. And we did that initially with 8 countries, and it was a big success. And we were absolutely delighted then when NICFI took a responsibility, because it's a very difficult process to do a public procurement. And then NICFI satellite data program emerged, and it's been a real game changer. I'll quickly provide 2 examples from the countries, and it would have been great to have the forest countries here, but I'll speak on their behalf if they don't mind. So the first one is Ghana. We've been supporting them for several years to improve we call it activity data in the context of REDD+. It's basically change in forest area and reporting that using a reference level, then reporting against it to receive REDD+ results. But we worked with them using our platforms, and thank you, Daika, for the kind comments on CEPAL. We used our open source platforms and the NICFI satellite data to help them show their results to the World Bank, firstly, and they were able to access $5 million from the World Bank's Carbon Fund for reducing emissions from deforestation and forest degradation, but also enhancing removals from afforestation and reforestation in their cocoa forest landscape. So the government of Ghana had acted. They used this new data. They used our platforms and tools, which we're very proud of, to report this progress and receive funding for this. And for the forest countries, this is extremely important because it allows them to raise their ambition, to reduce deforestation further, to enhance their forest carbon stocks much more. And another great outcome for Ghana is that their new data is also compliant with the R3 standard, which the LEAF Coalition has selected as their accounting standard. And now we see things like the LEAF Coalition, which is a big public-private incredible movement. I think they've raised over $1 billion, and this is such an exciting opportunity for the forest countries. So using this data, using the tools and technologies that are available, we're really busy at the moment supporting other countries on a similar pathway. So to improve their data, to access results-based finance, and participate in some of the emerging opportunities such as LEAF. The second example, is from Central Africa, and it's through the Central African Forest Initiative. We've been working intensively with DRC, Congo, Gabon, Cameroon, Central African Republic, and Equatorial Guinea, really to improve their understanding of what is driving deforestation and forest degradation. And we used the NICFI satellite data program, we used the Copernicus, the Landsat time series, and we really helped the country technicians create data for those drivers. And this is significant because yesterday we talked a lot about turning data into action. And now through CAFI, the countries are looking at how they can basically change their land use to tackle these drivers of deforestation and degradation. So I think that's a fantastic example of using the NICFI satellite data program to create great data and then turning that into climate impact. So that's an ongoing activity in CAFI, and I understand that investments are now being framed around this data to basically tackle the drivers of deforestation and degradation head on. So 2 examples, and maybe one challenge to everybody here. From FAO, we think a lot about the sustainability of our support to countries, and that's why we've leveraged hugely the Copernicus and the Landsat time series. And the NICFI satellite data program has been a game changer, and I know that it does have a shelf life, but I'd love to think about how we can move this resource into the public domain, because the countries are using it, as we've heard, and that's a challenging question for everybody. Maybe we can tackle that.
Yeah.
Thanks.
Thank you, Julian. And I think, as you say, it's now we're starting to see countries who are using this data in their UN FCCC reporting and actually showing such a high value in terms of the return that they're getting from using this data. They're getting more accurate estimations, and of course, as you were mentioning yesterday in one of the panels as well, the kind of value return that they get as a country in terms of these benefits that they get for reporting that and accurately measuring. I think you touched on a really important point right at the end there about the sustainability of initiatives like this. And Deveka, maybe this is a good time to ask NICFI in terms of, as this is a NICFI-funded program, it does have a shelf life. Perhaps you could talk to the perspectives of NICFI about this initiative and what might happen or what the view is post-2024.
Sure, and I think the minister also touched a little bit on this yesterday in his opening remarks. But NICFI has, of course, provided this data to the world for free for the past 2.5 years, and we believe it's been a very successful sort of pilot program that it's shown the importance of this data in terms of stopping deforestation. And we are, I think, strengthened in our belief that this should continue to be a global public good in light of the ongoing climate and nature crisis. And I think we are also encouraged that this perspective seems to be shared by many other actors, including those of you who are responsible for Earth observation and development of satellite imagery. Now, the current contract, as we know, runs out in September 2024, so a bit more than a year from now. And from what I know, there will be a gap between the end of our program and when the Copernicus high-resolution satellites come online in 2032. There is other data available, but not with the same quality, granularity, frequency as what we are currently providing. So NICFI cannot alone continue to provide this data to the world at the current cost, but we are open to exploring partnerships with other funders so that we can continue with this public good.
Thank you. And I think that's really good to hear, hopefully, for others in the room. And maybe it will provoke some more questions. Please do use the Slido app to ask questions as well, so that we can challenge the panel with some of those things that you would like to know. But I think the future of the program is critical. All the discussions I've had here and then events recently is clearly shows the benefits. So now it's how we actually make that happen. And perhaps kind of thinking along the same lines when it comes to programs, initiatives like this, if I take it back to the commercial satellite side and perhaps direct to you, Rolf, first, and then on to Will. is how can the commercial sector, from EO perspective, do more with these types of initiatives, and where do we go from here?
Yep. Thank you. It's a very good question on what do we do with data continuity? How do we get away from the shelving of an excellent program? And I think this is, again, a good example on the partnership here, because there's a duality here. I mean, obviously, the NICFI program has to show some initiatives on their ambitions to expand. Then we can help enhancing it, because if you just go on doing what you have done, you will kind of lose interest and at the time die. So we have to be innovative. We have to come up with new ideas. We have to come up with how can we enhance it? Can we add different parameters into the program? We had a conversation this morning that touched upon exactly that. So that's one parameter, one dimension. The other dimension we can throw in is how can NICFI as a framework be expanded to other areas? Can we leverage of the creativity in the program to start looking for in monitoring of the Arctic, for example? So again, in the period before the current program ends, we should get together and challenge one another on what's NICFI 2.0, because 1.0 has been a success, and we just have to move on.
Will,
yeah, well, I mean, I build exactly on Rolf's remarks. I mean, look, to Neil, your point, I mean, we're in a climate and nature emergency here, and we can't be in our silos. I mean, this is just crazy, and this is why these public-private partnerships are exactly what we need, I think, to break out. The private sector has some data to offer, the public sector has some ways of driving new mechanisms and markets. And I mean, I think to Rolf's point, I think in terms of extrapolation, what I'm most excited about is how we can now move into not just forest extent, but forest carbon. A planet, we have these 200 satellites, but we're also trying to build certain standardized analytics. We call them planetary variables: land surface temperature, soil moisture, above ground carbon, above ground biomass. The one that I'm most excited about is above ground carbon. We have a small team that's building, literally almost down to the tree level, carbon measurements of forests. And if you can get an accurate measurement of carbon, then you can underpin carbon markets. I mean, a long-term extrapolation of how we can talk about the future of NICFI in a way is how that becomes something that a market pays for in a transaction between countries and companies that want to buy carbon and the sellers of those and supply, if you like, of that carbon in the form of the countries that, in any case, we are trying to help protect those lands. Actually, an advantage of that is that it can even get down to the indigenous communities that safeguard, you know, a significant fraction of our forests and nature. And to the extrapolation point to other areas, this model can be used in other areas. I mean, I could look at FAO and talk about some of the priorities they have, as an example. Agriculture, well, satellite data can be, agriculture and the transition to sustainable agriculture is a cornerstone of our ability to meet our climate and nature and biodiversity goals. And we can imagine a similar monitoring system for monitoring sustainable forests, sustainable agriculture practices like tilling and cover crop use and things like that. That can be done from space and in a uniform way, just like we're doing with the forests. In fisheries, we can monitor illegal fishing off coastlines. That's another prerogative of FAO. One can imagine extrapolating this sort of program to other areas. It's a novel model of public-private partnership that I think can help us to tackle, and you know, to Julian's point, it's not just enhancing countries' ability to do it, it's accelerating. I mean, we have, again, we've got to make a right-hand turn on tackling nature and climate. And these are the tools that can empower that transition to happen in 1 year or 2 years rather than 1 decade or 2 decades. And that is what we all need. They're globally scalable. So as soon as you get it working in a small area, you can extrapolate to the whole world. And that's exactly what the world needs at this crucial time.
It's perhaps easier said than done, though.
Sure. Well, it takes consortiums of actors coming together, breaking down those silos, and I think what you're hearing here at this conference is a lot of not just on this panel here, cooperation and intent and similar goals and a mindset to do that, right? Space is, traditionally, and I think this is why this IAF Congress is so good and why I'm here, is that space has been so focused on itself and scientific missions and exploration. But Earth observation is the critical way in which we can help people on the ground. And this focus point, there's no more urgent thing for the space sector to be applying its muscle to than this climate challenge. And I think everyone has a similar mindset here. So I think we're in a collaborative spirit.
Yeah, definitely. And perhaps moving to the kind of private sector in this regard, because this has always been a little bit more challenging in terms of data access, and there's some questions here which I'll come to shortly, but speaking to the not-for-profit access, that this data is being provided as a public good. It is a non-commercial resource, but it is being used by private sector to help with their zero deforestation reporting, because that's not a profit-gaining element. That's where it has, of course, benefit. And of course, as we move towards this EU directive, that perspective might change, because of course there are then additional regulations that haven't been in place anymore. And perhaps, Niels, you could maybe comment on, as we move forward towards that, what's the impact that you see on these types of initiatives, and how they also need to be shaped to be either more broad or more accessible to the private sector as well as to the other entities, all of whom are contributing towards climate goals?
Right. I also might have included maybe a critical note, but I also want to say that the NICFI program is fantastic, because I brought in the example of the 1 kilometer data, and now we have much, much higher resolution. And it's important because a lot of the commodities produced are produced by small farmers. They get lost in a 1 kilometer pixel, right? So you need to have the detail to monitor them and make sure that they are included, that they gain access to the international markets. So that is where the NICFI work is fantastic. And I was also a bit triggered that I think that there is so much more potential that can be unlocked. I think from this discussion that actually the private sector can be the gateway to the private sector, which is like all the corporations that I mentioned. It is even the farmers' organizations. We can be that extra link. We are working on public data, satellite data, because otherwise it gets also not feasible for many big corporations, like a Mondelez. They source from 1,500 companies around the whole world, palm oil, for example. With hundreds of thousands of farmers and farms, etc., you need to monitor everything. And that's also why it is super cool that the entire tropics are covered. That's very important. So, gateway to the private sector by the private sector, I think that's a nice thing.
And that leads on nicely. We've had some questions from the audience. One of the questions we've had is, and I think this is a general question to perhaps this group here, do you think that European culture has an aversion to companies making profit, and that is hampering the speed of response to climate change? It's a really good question. Is that leading to some barriers?
Definitely. Next question. I mean, no, you're right. I mean, come on, we definitely see that. I mean, we're an American and European company, and we find a very different level of reception in the US from governments to leveraging technology. There's very much a buy what we can, build what we must attitude. And I just don't think that has happened yet in Europe, and I think that would be a very positive transition that enable us to go faster. What Europe has right is much stronger and better environmental policies. I mean, the policies are all there. If you look at the European Green Deal, to take the biggest actor here, all of those priorities, protecting the forests, helping the fisheries, enabling us to protect biodiverse regions, and so on, and transitioning the common agricultural policy to a sustainable one, can be advanced with space technology, but most of it is in private hands. And so we need to work together, and that needs to be a collaborative spirit. But I do see there's a lot of interest and intent on that. But yeah, there are barriers. And I think that if Europe flipped, it wouldn't just be that it would benefit and accelerate those policies. It would be also that it would build up capacity to then help other continents do that faster as well. So I see it as doubly short-sighted to have that attitude. And of course, it's not universal. We're talking, we're making generic statements here, but
you made a very clear answer to that one, and one can continue on and say there are no free lunch.
Yeah.
But that doesn't mean that everybody's out there to squeeze the most out of everything, because we have a common responsibility to make that happen, to make the efficient utilization of the data. And again, since NICFI is the common team here, they did an excellent job in negotiating a deal that wasn't commercial viable before NICFI. There was no way that the satellite providers would give away, quote unquote, the data in the way they did, but with the focus on the common objective and the goals, the common goal to make this happen, they pushed the industry into something that was much less commercial than before.
And I think that that's actually a good point, because the industry also needs to change its attitude about this. This is a public good exercise. One of the things that I'm very proud of for Planet is that we went public as a public benefit corporation, which means that the fiduciary duty of the directors of our company are not just to shareholder value, they're to our mission, which is about using space to help life on Earth, essentially. And I think that that's a positive development, that other private companies should consider those sort of new forms that aren't just about shareholder value. This is about a public good mission, a societal value of a challenge we've got to tackle on the planet. And so I encourage other industry leaders to think about how they flip to that kind of model as well. So both sides have got some work to do.
Definitely, definitely, and I think that's it's a really good question, and I think it provokes this kind of discussion, and that we can learn from initiatives like NICFI, which is funded something that's completely unique, as you say, Will. This is not something that had ever been done before, and now it's making such a large volume of data available for what will be 4 years for the contract term. And Deveka, if I can come back to you, and we've heard a little bit from Julian about some of the examples from UNFAO in terms of how this data has been used, and perhaps if we kind of follow down that stream on some of the examples and impact that you have seen from NICFI's side, just as another way to kind of enhance this discussion on the value of these types of initiatives.
No, sure, and I think we've heard similar feedback as Julian was talking about in terms of access to satellite data really being a game changer for understanding and responding to deforestation in the tropics. Forest country governments are the biggest user group of the data. So Brazil, Colombia, Gabon, and many others. They use it to detect and validate and quickly respond to changes in the forest cover. Some have built sort of early warning systems using the data so they can detect forest fires, and they also use it to strengthen their capacity to investigate and prosecute activities related to illegal deforestation. And I think for this type of use, the high resolution and the frequency of the data has been particularly important. Another big user group is civil society at large, NGOs, media, academia, indigenous groups. Many civil society groups use the data to hold their governments to account for progress on environmental policy. We've seen some examples of indigenous groups actually using it to monitor their territories. So they download the data on their smartphones, and then they use that data to plan patrols where they gather evidence of illegal activities occurring in their territories. And they're handing this data then over to, or this evidence over to governments or local authorities for further action. So that's interesting to see the sort of very variety of uses. And then I think the last example is sort of private sector, where more than 2/3 of tropical deforestation occurs due to the production of just 4 commodities. So you talked about palm oil, there's beef, soy, pulp and timber. So obviously there is no way that we can reduce tropical forest loss without the collaboration of private sector. I think we're seeing a few examples of global companies using the data to sort of validate deforestation alerts in commodity producing regions, and to engage with their suppliers to address deforestation risk in the supply chain. But I do think there is a bigger potential for private sector to make use of the data in light of the EU regulation in particular. And I think this is maybe, and I wanted to ask you because I think this is where we've seen the least use, I think, in terms of the user groups. Yeah.
Perhaps Niels, if you want to speak to that.
Yeah, I think that is because of the distance. I remember going to the biggest agricultural bank, or one of the biggest Rabobank in the Netherlands. And I was talking to a banker. He said, "What are you telling me? It looks like you're from space." Well, in a way. We were talking completely different languages. So the gap is so big. And I honestly think that if you look at these corporations, Unilever, they're pretty advanced, but there's many more. They simply don't have the capacity to understand what's going on in a completely different sector. Maybe big corporations even have one sustainability person who has to take care of social things, environmental things, a lot of things. Then they have to learn about images and data, how can they use that? So that the gap is huge. And yeah, that's why I was also triggered by this conversation, that I think that if you think about it, as a private sector, a purpose-driven enterprise, we're more focused on actually the education, the hand-holding, as I said, and preventing people from drowning. And there's a lot of more potential there to have much better uptake of imagery. So we're happy to fill that gap in the community.
Yeah.
Charlotte, may I add on to that? Because you're hitting a nerve here. We're all, you said Space Geek, we're all so focused on what we're doing, and we lose a lot of the audience by staying tuned on what we think is the coolest thing on Earth.
Or offer.
And above word. So I definitely agree with you. So that's why we have in this partnership, there shouldn't, the value of communication shouldn't be underestimated. And you took the palm oil example. Case that is also looking for oil spill, and we find ships and stuff. And some years ago, outside of Denmark, there was a lot of tankers that cleaned their tanks before they went into Rotterdam to refill. And the mere fact that we announced that, hey, you are spotted, you are seen, we know what you're doing, had an impact. The same thing goes to illegal fishery, where we've done a couple of pilots where the fact that you broadcast that you are watched made a huge impact on the illegal fishery. So back into your palm oil example, it shows that being watched has an effect. And we should probably, as a community now in the Global Impact, focus on just let the world know that things are happening. Somebody up there, our big brother is watching. And you should announce that rather than being too specific in that niche or that niche. And in other areas.
Yeah, we actually had a really interesting example of that. The Allen Coral Atlas was built leveraging satellite data to monitor coral reefs and produce a map of them. And there's been 30 marine protected areas being built as a result of this map. And I was like, scratching my head, why? Sri Lanka already knew it had a coral reef, right? It's not like that can't have been news to them. But they didn't have a precise map of where it was. So this provided an actual information. Here's where the illegal fishing is on a day-to-day basis, or here's the early signs of ocean bleaching. But it also was the fact that it was being published, so Sri Lanka knew that everyone knew about its coral reef. So it upped the ante. So the mere fact of having the data out there changed policy. And I think that, so that's one of the powers. But, I do think that, to earlier point, the Earth observation community, the space community needs to get it out of its space head, and we've really focused on those solutions, the end game. And I think, the NICFI partnership again is a pioneering example of how to really bridge those gaps.
And it's transparency, and perhaps did you want to comment on that as well?
Yeah, I actually wanted to pick up on Niels and Deveka's comments on the upcoming EU regulation on the deforestation-free commodities. Actually, the NICFI satellite data program and the data is really good for that. And I think the countries at the moment, the producer countries that'll have to respond to this regulation, they have to feed their population and export commodities that are shown to be deforestation-free. This sort of data is really critical to that, actually, to benchmark their production cycles. So it's something that the forest countries are starting to think a lot about, and that's why I think the continuity of this program can serve that purpose as well, which we see a lot. I mean, the EU has a regulation, the UK and the US are not far behind. And we know that a lot of deforestation is driven by agricultural activities, right? So this is a great initiative, but the forest countries need to have capacity and data to basically respond to it and to comply and continue reducing deforestation but also feeding their population. So I just wanted to add that as another critical need for the NICFI satellite data program.
And if we're talking about data, from your perspective and from the perspective of the countries, the capacity building that you do, what other data sources would you like to see? Let's pose this question, because we have commercial satellite data providers on the stage, we have others here. What would you like to see from your side? And then maybe Niels can also comment on what he would like to see.
I think everybody wants
everything.
Super high resolution imagery, right? But it's difficult to work with. But that is what the country technicians like the most, right? Really high resolution imagery. But what is coming through the NICFI satellite data program sort of hits that sweet spot, right? It has good enough spatial resolution to do reference data collection, to validate your geospatial work. And also there's the level 2 data with the high temporal frequency, which is brilliant for things like early warning systems, fire response. So, I mean, I actually feel like that it hits a sweet spot. Of course, all the technicians want to see centimetre perfect imagery, but
get working on it.
Maybe in the future. Maybe in the future.
But there are two dimensions to this as well. One is the amount of data, the type of information that you can use to come up with the final product that you're going to act upon. And in some areas, it's also timeliness. Because if you're going to watch a wildfire running wild, then you should have information available there at the time, so you can guide the firefighters to go and do what they want to do. So again, it's a super complex thing here. I mean, and the framework that we created with NICFI is a beginning that can be expanded in a lot of dimensions, and I think that should be a focus for
the temporal dimension is just as important. Actually, I think that the space community over-focuses on the spatial resolution piece, and as you say, technicians, that's what they're used to, but temporal resolution and spectral resolution are just as important axes. I also think that we're seeing, and perhaps this is where this is going in the future, is most exciting is less about the satellite data again, it's more about the analytical services that sit on top of that. I think there's a massive potential for more. I mentioned the carbon sort of variable that I think that we will help to do, which the community I think needs. There's millions of others that can be extracted out of Earth observation data. And artificial intelligence and computer vision, machine learning, computer vision in particular, is showing itself to be tremendously capable of doing these things in ways that are easier. So it becomes easier and easier for people without satellite imaging expertise to extract value out of this data. And I think that is if there's anything that's happening in the next few years, it's going to be less about all the extra data, although there will be extra data. It'll be more about where the analytical services can go that enable us to democratize access to that. So it's not just NASA or some large entity that can get benefit from our and other people's data sets, but rather that person on the ground that's trying to protect their biodiverse ecosystems, and they don't know how to look at satellite data, and they don't know, especially not to look to hyperspectral imagery or all the other analytical components. But soon you'll just be able to ask it a question, like you can ask ChatGPT, how's my biodiversity doing? Oh, well, you've got fewer of these trees and more of those trees, and this is what's going on over here, and that's correlated with these kind of animals on the ground, and that's going to help us to do biodiversity protection in a new way. As well. So really exciting to look forward to that.
And Niels, maybe you can comment, because I think this touches on a big point about the data, but also analytics. And you mentioned about the knowledge, this kind of gap between the actual need to understand the data.
Yeah, no, exactly. I think in terms of data, and I'm talking about deforestation, fires, thermal imagery would be nice to have continuity. I think continuity is the big thing. So the 3 to 5, the 10-meter data is great for deforestation, fires, etc. But we need continuity, and it might be a bit of hampering uptake of, for example, the Planet NICFI data, because we don't know if it's there in the future. We know there are Sentinel data is in the future, right? So it must also make business sense for us to roll out all the analytics globally. So that's also something we might want to talk about.
It's going to continue, one way or another. It's going to continue.
And maybe we have just under 5 minutes left. So maybe there's a question I'd like to pose to all of you for your perspectives on is we've talked a lot about that we need to collaborate, we need to do more together, we need to break down these silos. How do we do that? Do you have other ideas or things that you could bring to this discussion now that could start that? What would be the way we could approach it?
We start to talk to one another more than we do.
Well, yeah. I mean, look, I think that companies can do more to communicate what the new capabilities are. I think they can do more to think about applications and that downstream piece. This is an ecosystem approach. I think governments could lean in to adopting of these technologies to really have more flexible procurement mechanisms that enable that when this is a fast-changing, fast pace of change here in the technological environment. So you can't just say, let's plan this out for 20 years. It's just there's totally revolutionary technology in 2 months. So you're going to have to, it's going to be a very different dynamic procurement environment, which is totally new, right? But between those things, and then all the NGOs and the researchers pioneering where we need, what capabilities can be built from this, I think we're going in an exciting direction. So. Don't know if others have.
No, I'll let the other one talk.
Do you have any comments on that? What, in terms of how do we collaborate more? And obviously, UNFAO, as you said, you put out this public procurement some years before NICFI did, and it's tough to do that. And how do we collaborate more to make those more successful and more accessible to everyone?
Oh, it's an amazing model, and I'm very interested to think about replicating it. But then you need some strong donors or some strong corporations to get involved. Maybe the next step is to bring in the private sector, not just the public finance on a renewal like this. But yeah, just from our side, I mean, 11 years ago, we decided to switch to fully open source technical solutions, which works for us very well. And in fact, the sort of work that Niels is doing, often the private entities who are driving innovation, creating incredible algorithms, are contributing to that as well. So it's just an open call to everybody that's innovating, creating data. That's, if you want to contribute to our open data resource, which is all on GitHub, you're very welcome to, because the countries are there and we can move your innovations to operational applications in forest countries. But I'm very interested to, I'm very hopeful that the data program will be extended in some form, and it's interesting to think about how we can replicate it, because it's been really successful.
Thanks, Julian. Deveka, Niels, any comments?
Yeah, I think definitely more collaboration. I think with the new EU regulation, it's important to extend that dialogue to include more forest countries and also a more diverse group of private sector. Obviously, the commodity producers, traders, but also financial institutions, regional banks, and so forth that have an interest in this and in using the data. I think that's one. I think we also need to talk more across the sort of carbon community and the biodiversity nature community, because I think those work a little bit in silos. And I think we're seeing now that we've been very focused on measuring carbon, and we're able to sort of, there is one unit for that, and we can put a value on that. But now we are also seeing in our conversations with partner countries that, hang on, we need to also put the value on all of that biodiversity within our forests. And how do we do that? It's much more complex. There is no one single unit of measurement. And I think it'll be exciting to see how satellite data can contribute to take that discussion forward.
Yeah. And Niels, the last word is yours. Comment from
let's continue the conversation.
Yeah. Fantastic. Well, it's been a great panel. It's flown by. I would love to ask more questions, but I want to take this opportunity to thank Will, Rolf, Julian, Deveka, and Niels. And I hope everyone here has also enjoyed this very active discussion, I think, on how Earth observation data can support climate policy. Thank you very much.
Thanks a lot.
Thank you.
Thanks a lot, Charlotte, and thanks to all the speakers. May I ask you also to come here for a group picture of this panel? Please. So while we are doing this, I just want to tell you that we now need to break again for a coffee break. Please be back sharp at 11 o'clock. We will convene again, and if you could help us to free the room as quickly as possible, because we need to do a reconfiguration. The technical sessions will also continue now in the side rooms and in the Scandinavia scene room. Ladies and gentlemen, welcome back. We will now proceed with our program. But before doing so, let me start with a quote by the Secretary General of the United Nations, Antonio Guterres, saying that carbon neutrality by 2050 is the world's most urgent mission. And in this spirit, this next GNF session is focusing on the carbon footprint of monitoring climate change from space, organized by Ariane Group, and it is my distinct pleasure to welcome as the moderator of this session, Professor Pascal Erdenfreund, my dear friend, past president of the IAF, and now president of COSPA, and of course president of the International Space University, ISU. Pascal, please.
Thank you, Christian, and I think the doors are closing. And I really want to welcome you to this global networking forum on the carbon footprint of monitoring climate change from space, also from the industry and agency level. I think we have discussed a lot during yesterday and this morning. We had plenary lectures, we had highlight lectures, we had forums, and we had technical sessions. And it is clear how important, of course, all the satellites are and the measurements we take for our future to combat climate change and go into the future. But monitoring climate change from space also involves a carbon footprint, primarily due to manufacturing, due to testing, to launching satellites. And all these activities, they require energy. They often require carbon-based sources, which contribute again to greenhouse gas emissions. So we also know the space sector is booming. We have a large number of satellites and launches. Everything increases extremely rapidly. And what we want to discuss today, and I think that's a really great continuation to all the panels and all the new scientific knowledge and policies which we discussed in the last days, we want to discuss the impact of this carbon footprint of various space activities and also review the concerns, but also look what's already done. What are the measures which are already done by the industry, on the agency level, and see what is there to do and how complex is the whole system. So this forum is also an opportunity to highlight the recent signature of the joint statement for a responsible space sector under the leadership of the European Space Agency. And this session, as has been discussed, is organized by Ariane Group. And I would like now to introduce my really distinguished panel members. And number one is Aurélie Gallis from the European Space Agency. She is the Climate and Sustainability Officer. Then I want to welcome Thomas Marceau. He's the Head of Sustainability and Corporate Support at Ariane Group. Cedric Balti, Director Innovation and Chief Sustainability Officer, Thales Alenia Space. Then we have Mathieu Derey, a Space Product Sustainability Manager from Airbus Defence and Space. And Sabrina Alam, Head of Space Sustainability and ESG Program Manager from SES. Sorry. So I think something which is, I think, quite wonderful is that you see that measures are already taken, because all of my panel members, they do have a title, namely Sustainability Officer or Head of Sustainability Support. So there are already activities going in this direction. And I think that's a really, really good sign. What we're going to do is we're going to start with some opening statements. And you also know you can ask questions through the Slido system. They will end up here. And so we will start with some kind of opening remarks. We have also some supporting slides, which will be called from time to time, because it's a quite a complex problem, and we really need sometimes the overview over the entire ecosystem of those activities. And so I hope that you will be active and asking us questions, because I think it will be really, really an interesting session. And I'm going to start at the beginning to ask some questions for an opening statement. And I would like to ask Aurélie Gallis. So what are ESA's actions towards decarbonization and of all the different activities?
Thank you, Pascal. And indeed, at ESA, we have important targets that we set up in the ESA Agenda 2025 towards decarbonization of space activities. So ESA strives for being a role model as a global and a modern space agency. And for this, we have two main targets. One is what we call the handprint, so increasing our handprint, so the contribution of the project to sustainable development of society. So it is traduced into the Agenda 2025 into the way that ESA ensured that ESA and European Space Programme can support the implementation of the Paris Agreement and the European Green Deal to the fullest extent. On the other side, we are working on our footprint, so ensuring that we decrease effectively our footprint, ensuring the socially and environmentally responsible management of our activity. And we have the goal of decarbonize our activity of 46% at the horizon 2030. With regard to the baseline of 2019. So for what we call the scope 1 and 2 of our carbon footprint. So we really work on this both target, so having the improvement of our handprint and the decrease of our footprint. And for this, and in order to turn our decarbonization targets into action and address the sustainability objective of the Agenda 2025, we have set up what we call the ESA Green Agenda, which is organized into 5 main axes, and with the goal to reach the 2030 targets. So these 5 main axes are, the first one is to adopt sustainability objective for ESA project to increase the benefits of the benefits of the programs. So again, the handprint. The second axis is to reduce the environmental footprint of ESA assets, so including the technical and non-technical facilities. The third one is to reduce the environmental impact of our programs and of the life cycle of the space system. So we really deal here with life cycle assessment and eco-design. For the conception to the exploitation and of the space system, and of course we work in close collaboration with space industry. The fourth axis is to enforce the ESA responsible procurement by engaging our suppliers along the ESA corporate responsibility principle. And for this, we have developed a code of conduct for the suppliers. And the fifth target is to promote cultural change, so bring awareness, developing a structural change management approach. So that's the main axis we are working in. And as a conclusion, we are working on all perimeters. So again, this question of reducing our footprint, improving our handprint, but also working in collaboration with all the supply chain and the space industry.
Well, thank you, Aurélie. This is actually quite a complex framework, and there are many, many different parameters. And I think we will get into detail of some of them, also with the other speakers. Thomas, you actually suggested the idea for this panel. So what are the stakes for our young group?
Well, first of all, I'd like to thank the IAF for allowing this panel to take place, because we've been hearing a lot about all the advantages that space can bring in order to fight against climate change, in order to monitor all the parameters of the planet, the temperature, the ice, the sea levels, and so on, which are entirely important, crucial for the fight against climate change, and we are definitely in support of that. And that's, I mean, that's our purpose in Ariane Group, to make space available for the benefits of all mankind, for all citizens in a safe world. That's our motto, and so we definitely support that. But that shouldn't prevent us from taking care about our own impact. Because when we talk about space in the public society, they don't think about the satellites that help them navigate through the cities. They don't think about the satellite that help them communicating with cell phones. They don't think about all the applications that satellites bring in order to help with climate change. They think about the impact. And I've heard a very interesting, actually a very interesting roundtable yesterday right here about communication relating to space activities, and the questions are really about our impact. When I go to schools, when I go to a university talking about what we do and all the benefits that we bring, the first question I get is, okay, but what is your impact? And this is definitely something we need to address, because otherwise, if we don't address that question, then all the benefits that we can bring, we'll lose them. So definitely we need to focus on our own impact, and that's, I heard yesterday someone saying we need to walk the talk. And yes, we definitely need to walk the talk. And space for decades was, I would say, an institutional business. It was driven by agencies, by governments, by institutional actors, but now there are plenty of newcomers. I've read on my way going to this conference that there are currently 160 new projects of launchers being developed all around the world, 160. And all these launchers, they will not launch only Earth observation satellites, and believe me, they are not here to monitor the planet. So we need to focus as well on the impact of the global space sector in order to be sure that this tool, the space tool, the resources that we get from space for space innovation, space observation, are sustainable as well. So that's why we wanted to propose this roundtable to show that we need as well to take care of our own impact. That's what we started in Ariane Group as well. We are working with ESA, Aurélie mentioned that. We are conducting what we call life cycle analysis to analyze what are the impact of each and every step of the production process, from the cradle to the grave, from the first element of the rocket launcher until the end of the mission, the dismantling. And we need to collectively, I think it's the whole point of this roundtable, to collectively as a sector address this question, to have common tools, common methodologies in order to address this impact. That was the whole point of my proposal for this roundtable.
It's a large topic, and we will not be able to go into every detailed aspect, but we got already quite some interesting questions from the audience, so very in the first minute. Yeah. So Cedric, what is Thales Alenia's perception of sustainability for the space sector, and what kind of methods do you have to address it?
Yeah. So first, I would like to echo to the comment of Thomas and Aurélie. I think definitely, if we are here, we are already collaborating on various aspects. It's really an ecosystemic approach, and if we are providing solutions to try to help and solve issues on the planet, we also need to take care about our own impact, as Thomas said. And maybe something important to remind, it could be carbon, but in our industry it could be different things than carbon. So carbon is not the only topic we need to tackle. So we all have this type of 50% decrease of carbon footprint for us, at least in 2030. But it's more or less the same type of objectives that we have from one company to another. But we need also to take care about other potential impacts on biodiversity. We know that the launchers could have other type of impact. We don't really know what is the impact of a satellite, which is burning in the atmosphere. So these are things we need to tackle. We also need to tackle the outer space. So we are sending things up there. What happens is they stay up there, and how do we manage the debris? So this is also about sustainability. In Thales Alenia Space, we are really starting a journey since a bit more than a year now, and tackling it quite holistically and globally. There is a very, let's say, first important step is how can we engage our teams, our people. And just when we created this directorate around sustainability, there has been spontaneously many people coming to us. So we want to engage our employees. We want to train and bring awareness to them, and we want to leverage all this energy for the company to be able to tackle these challenges. So that's one of our strong strategic axes. Definitely, we want to tackle sustainability and go as far as possible into circularity when it makes sense. And we want also to see how space could contribute in a wider way to the global challenges of our planet. So it's a quite holistic approach and the starting point of a quite long journey, probably.
Thank you very much, Cedric. I think after the opening round, we will probably show those slides, and you can all speak a little bit to it, that the people understand how complex actually the topic is. So I would like now to ask Mathieu. You are from Airbus Defence and Space. So what does sustainability mean for ADS, and what are the stakes for the space sector?
So thanks for having me first here around this round table. It's very important for me to talk about the footprint, yes. So far in this event we've been again talking about a lot about the handprint, which is, yes, what space is bringing to humanity with Earth observation, connectivity, science, but very little about the footprint. So very good. This is what we mean by footprint is, if I make it simple, not too complex, this is about the resources that we take for creating our product and the waste we are producing, simply. So what at stake for us in the space sector, indeed, is to, for example, when you take the finance sector and you need some funding for your investment, you go and ask for money. You build your business case and you ask for, you explain what will be the future revenues. But of course, it wouldn't work. You wouldn't be credible if you don't expose also what are your costs. So to be credible, we need to do the same here. Talk about what we bring and also what it costs for the environment. So in Airbus, sustainability is at the core of our purpose, so which is we pioneer sustainable aerospace for the safe and united world. We have 4 pillars. The first is lead the journey toward a cleaner aerospace. The second, respect human rights and foster inclusion. Third, build our business on foundation of safety and quality. And the fourth, about business integrity. And of course, today we are here to talk mainly about cleaner space activities and our journey within this. And as a space manufacturer, which is my responsibility, our responsibility as a company, we have a few hotspots, and we will come back to them on greenhouse gas emissions. First of them is mainly about scope 1 and 2, meaning, yeah, maybe we can show the slide directly. So this is from the greenhouse gas protocol. This is a framework not for space, this is for all the sectors, where you see the scope 1 direct emission from the companies for their operations in their facilities and the company vehicles. The second is first indirect, but very much related to the activities of the sites with purchased electricity and steam, heating, and so on. And the scope 3 is quite vast with a lot of upstream activities. Mainly for us, we are talking about purchase of goods and products. And the downstream part of the scope 3, we have a lot in the use of sold products. And you see some other activities. And here are the hotspots, yes, for us. Scope 1 and 2, yes, the buildings for the operation of test facilities, IIT rooms, Also the tertiary buildings for all the engineers. This is a hot topic. Also, we have the commuting and business trips. Today, we have a footprint with this event. I don't know what is the computation in the end, but there's been probably a lot of travels. And a third one is related also, and that's something that we are doing together with ESA and the other actors, is looking at the product's footprint with the scope 3 purchase upstream and utilization downstream that probably Sabrina will talk about.
Yeah, I think this is, thank you very much, Mathieu. This is, I think, quite important, informative for, people here in the audience, which are, coming from a different field and want to see the whole picture. It's not so easy. And I think a lot of people are also not familiar with what is scopes 1 and 2 and 3. So I think it's important also to bring that much more into the discussion and with public relation material, so that people really understand this complicated cycle, and that actually industry and agency level, organization level are already really working on that. So Sabrina, I'm coming to you. What does sustainability mean to SES and also the wider industry?
Sure. Well, thank you. Firstly, thank you for the opportunity to be here today as well, and thank you for the invitation to SES. So one thing I want to address is that I think there's a common myth that tackling sustainability or climate change is easy. We hear a lot about just do it, why don't you measure your emissions, oh, you need to reduce your emissions. And whilst that's 100% true, it's not simple. It is a journey, and we saw on the slides there are scopes 1, there's scopes 2, there's scope 3, but it actually goes way beyond that. And when we talk about sustainability in general, we're talking about everything from the environmental side. So as Cedric mentioned, biodiversity, eutrophication, ozone depletion, so on. We're also talking about the social aspect. How can we expect to solve climate change and solve the climate crisis without thinking about the people around the world that also contribute to it or are going to be suffering from it? And so that's one thing that we need to address. And then on the governance side, and I'm talking from a very ESG perspective here, but we need to think about what countries have different rules in place. What are the regulations? What are the trends at the moment? When we talk about sustainability, it has to link with business objectives. There's no point just saying we're going to do something completely different, because your company won't adopt it in the right way otherwise. It needs to make sense for your company. And so when we look at sustainability at SES, we look at it within 4 pillars. The first being space sustainability. Of course, we're a satellite operator. We have a duty in space that we need to tackle. We look at climate action, and so that's looking at how we achieve our net zero roadmap. How do we actually go beyond just saying we're going to be net zero by this time, but actually doing it in an accurate way? And so actually, we've all had discussions here because we've reached out to create partnerships on life cycle assessments, which should accurately tell us what our footprint is and how we can reduce it. And it goes beyond that, where we have a concept called eco-design. How do we then use the information that we've gathered to actually reduce our emissions and do better, innovate better, design better? And then on the other side of it, it's also working with the industry, being at these kind of events, talking about it, making sure that within our contracts, when we talk to suppliers and vendors, we're telling them, what are you doing to reduce your emissions? What are you doing for the planet? Do you even have a strategy? And at some point, what we want to do is be able to actually create this kind of rating where we say, you're not looking at sustainability properly, so we're actually not going to select you. And so it goes beyond this kind of finance risk metric. It goes into that third category where we talk about impact. And so at SES, that's what we're doing. That's the journey that we're currently on. And I can tell you now, it's not easy. It's not something that we woke up one day and said, let's do this, and it was done. It's something we're still in the process of. We're still creating those partnerships. We have these roadmaps. And it's partners like you all, it's partners like everyone who's here that's going to help us achieve it. And on the other side, and as a corporation, maybe I shouldn't say this, but actually it's consumers. Consumers have such high power that you don't even realize. Our customers had to ask us, what are you doing from a climate perspective? We want your data. That's a huge incentive for your company, your senior leaders, to actually say, okay, I need to think about this because it's going to directly impact my business and the model that I have going forward. And so we have loads of different drivers from all areas. So sustainability, in a nutshell, really means making sure our business, our operations are having a positive impact on the planet, on people, and we reduce the negative impact from all dimensions.
Thank you very much, Sabrina, and I think that showed also the different categories and also the interest for the industry to move into this topic. I have a combination of questions, and please let the staff know if we should show the second slide or the first slide again, because of the complexity of the topic. I want to actually combine one of the first question of our audience with something what we anyway wanted to discuss. We need a regulation on how carbon equal footprint is calculated by the space sector to have comparable figures. How is this organized? And we actually wanted also certainly to tackle what is the major, or what are the knowledge gaps, related to the space sector footprint. And maybe I start with you, Aurélie, and whoever wants to continue.
Yeah, sure. In terms of regulation of eco-design, or at least guidelines that we can all have together within the space sector. At ESA, we have the Clean Space Initiative, which is leading the life cycle assessment and eco-design expertise since 2010. And for this, they have been working on guidelines for the space sector, well, building the framework actually for the space sector. So providing guidelines on how to do life cycle assessment for the space sector. If a company or an academia or a space agency want to run a life cycle assessment, so what is the basis of eco-design, life cycle assessment, etc., which kind of environmental indicator we have to look at, for example. And they have also been working, and there is a work ongoing to update this, the life cycle, the space life cycle database. So the space sector, in terms of for doing a life cycle assessment in the space sector, you need to have specific data sets, because materials are specific for the space sector, some processes are specific. So the data sets that we provide are very useful in that sense. And of course, we know that we have gap analysis, some gaps in this in data sets. And we were mentioning at the beginning that, for example, atmospheric impact is something that for today we don't have. So we are working on the update and improvement of all the framework, I would say, to help really the space sector working correctly in eco-design and life cycle assessment. And maybe we can put the second slide, I think, so we can explain what is really eco-design. Well, eco-design, it's an holistic approach, and when we speak about life cycle assessment, it's basically the most powerful methodology we have, a scientific methodology to evaluate the environmental impact through the life cycle of a project. So really going from the extraction of resource to the end of life of the product. So it's an iterative, the eco-design is an iterative approach, so that's why we need data to do life cycle assessment. We need to do also hypothesis, because if we want to do an eco-design process from really the beginning of a program, we have to rely on hypothesis and data set. But really the core of eco-design is to improve the environmental performance of a project without reducing the final quality or performance of it. And if I can maybe end with eco-design guidelines and directive. At European level, there is also the eco-design regulation and an objective to have common way of doing also life cycle assessment, which is called PEF, the Product Environmental Footprint Rules.
And maybe to comment on the question of the gaps you mentioned, to be very, very short about that, but when we talked about the various scopes, scopes 1, scope 2, scope 3, scope 1 and 2 are mainly about what you do on your site, the energy you consume, the greenhouse gases that you emit, but that's on your site, that's within your premises, so to speak. So that's something you actually kind of map quite easily. It's not perfect, but you map it quite easily. But what happens upstream and what happens downstream, it's a whole new territory. And depending on what we call the emission factor you use, for example, if I buy 1 kilogram of this material, or if I buy €1 of this application or whatever, you can have factors from 10 to 100 to 1,000, depending on the emission factor you use. And we also have huge uncertainties about the use of our products. For example, we, for space launchers, we don't know exactly what happens during the launch phase. We know quite well what happens on the ground, but when the launcher lifts off and it goes through the various layers of the atmosphere, it emits various byproducts of the propellants, and we don't know exactly the effects of these products. So it's a brand new territory, and it's very complex to map what happens behind and after what happens in-house. So we definitely need some common rules, common methodologies, common referential to say, okay, if I buy 1 kilogram of this, that's one kilogram of CO2 or whatever.
And I'd just like to further complement. So one of the reasons why I love this panel is because you have your manufacturers, your launchers, you have ESA, who kind of looks over the European space domain, and then you have the satellite operator. So hi. And one of the things that we're doing for life cycle assessments is connecting with each of you, because we can't do this alone. SES, for example, we purchase our satellites from the manufacturers. We then say to the launchers, we've got 2 major ones, hey, can you launch our satellite into space? And then when it's in space, it's floating around, we've got our operations team, but actually and we also have our ground infrastructure as well, and there's so many different pieces to it, and every single one of them contributes to what we call the scope 3, which makes up 90% of SES's emissions. And that 90% is so, I would say the data is very unreliable because we don't have this concrete data. So how do we get it? We come to our value chain and we say, hey, we really need this data. Could you help us? Let's conduct these life cycle assessments together. Now, the issue is when you go into legal confidentiality problems, that's when it becomes a whole different domain. How are we able to share raw data? How are we able to still remain within competition rights? How are we still able to remain, I would say, legal in terms of what data we can share? And there's so many different complexities around that for us to say, let's address climate change properly, let's get accurate data. Now we know exactly what the value chain is doing. We can say, all right, this is what our real, these are what our emissions are. And I don't just mean carbon dioxide, because I think that's another myth that carbon dioxide is the only contributing emission to climate change. I'm talking about the whole set of GHG emissions as well. So it's about finding a way to navigate these issues and these challenges, and the way we've done it is through connecting with partners and asking them to do a section of this, the constellation, us to do a section, the ground infrastructure people to do this, to do a section, and so on. But then you've got to think about the way that space and our industry is so global. Why is it that the US have different rules to EU and so on? So where EU-based companies are almost going to be obliged to do this work because of new regulations coming up, like the CSRD, US players don't have to. So what's the incentive for them to then work with us to give that information? So that's just a perspective I wanted to share there. I think
to complement on that, on the international aspects, there is also the fact that there is the methodology also on the way to account these things. Of course, scope 1 and 2 and 3 are general to all sectors, as I said, but we have some specificities in the sector with, for instance, the aluminum that we use is not the same, the propellants are different from other sectors, so we need to compute those data, we need to share those data, and we need to have common methodologies for that, and that's why we are working with the International Aerospace Environment Group, the AIAG, to start looking on those methodologies and way to compute the data based on the aerospace, which is a bit more advanced on those topics, and because it's a bigger sector as well.
Cedric, also before we, because I think the audience is a bit overloaded with all the different unknowns and gaps and things. It's a new topic. We have to orientate ourselves. We have to build it. Sustainability offers are more or less a new category in many companies. I would like still to hear your idea about gaps and what is important before we go a little bit more into the topic, how can we solve all that?
How can we?
How can we solve it? Later on, I think we have to discuss really what kind of regulations, what targets and so on. But concerning in particular the knowledge gaps, and do you still have something to add?
I think, again, it's a journey, and I would just echo to what has been said. I mean, Scope 3 is clearly an issue for all of us. Very interestingly, we're all working together somehow on these topics, because we are all, or most of all, Scope 3 of the other. So there's a huge uncertainty. There are gaps, I would say, a little bit everywhere. There are probably also new roles to play in the companies, new types of actors that we need to identify, to create, to position in the right areas. Maybe like quality was something new 30 years ago, something like that. I think sustainability is something new also in our companies, so there is a gap in terms of knowledge and how we tackle the topics. I think that's also fundamental. It was a very important point put on the table by Sabrina, is that we are in Europe, I think all of us individually are very much concerned, and we all collaborate. And then there is this regulation which is coming, which is helping us. But it's very important to keep in mind that we need to remain competitive with regard to our competitors which are not in Europe. And that's a fundamental issue also for us as an industrial company. So we are convinced, and we are working to change our ecosystem, our industry. But we need also to take care about how our competitors are moving in this direction, because sometimes it may have some impact on our costs. Sometimes it can have virtuous levers, so it's not always negative in terms of competitiveness, but it's really a key point of attention. So, I think a very important point to keep in mind, people have to change in the company, in their jobs, in their mindset. And we also need to be very cautious about our capability to continue and grow our business and not to be kicked away of our core business.
Sure. Thank you very much. We have quite a lot of questions, and I will try to fit them in, but I wanted to ask one thing because to Thomas, because you said I have written down 160 different launcher projects over worldwide. And somehow you have to understand, what is the global impact also of all that. So how is the international cooperation, and how do we actually work together in order to get more knowledge? You said that many of the parameters during a launch are not enough measured. Very much what's going on the ground at launch, but not in the atmospheric. There's a lot of research which is necessary for the future. So when you say there are so many launcher projects, is there a basis, a platform of discussion about those parameters and how you can, engage in data sharing?
Well, apart from the platform which are driven by ESA directly, not much that I know of. There are some researchers starting on the topic, because it's always a complex problem with various parameters. It depends on the type of propellant you use. It depends on the launcher itself. It depends on the fact which is a reusable launcher or an expendable launcher. So it depends on plenty of parameters, the size of the launcher, and so on and so on. So it's definitely a knowledge gap today. There are some early research about the topic, and sometimes some of them telling the contrary of the other. I've read in one serious article telling that we emit alumina when we use soil propulsion, telling that it could actually cool down the planet because it reflects some energy coming from the sun into space. And I've read in another article that actually it's a global warmer. So definitely there is a knowledge gap, and there is a huge knowledge gap on this topic. So today there is no, to my knowledge, no commonly shared database on this impact, and that's definitely something we need to work on. So we are working on that with ESA, of course, with all the Clean Space Initiative, with all the database which are being set up with ESA, but not at a worldwide level, definitely not.
Thanks very much. So I'm going to come to audience questions, also from John Reed. Are there standards, ideas for relative cost-benefit evaluation or merit of information sources? For instance, electronic interaction is less effective than in person. Is there anybody who wants to take this question?
I'll take it as a reaction.
Yeah.
So I'm not sure I can answer directly to this question. I think something very important is the fact to tackle the topics globally and to educate the people to understand what's at stake. Because you could have a standard which is locally, let's say on an equipment or on a subsystem, which makes a lot of sense, but it may disoptimize the system. So globally, your system may be generating more impact. And that's a very complex issue. I think it's just an illustration to show that, of course, that's a very good question, and we need to see how we can answer to it. But after, we need to be careful when we put it in place that when we are optimizing something locally, we're not generating a bigger impact because we need to improve or to change the way the rest works to cope with this evolution. So it's a really complex and global topic. So after directly, I don't have any specific answer to this question, but...
as I said, the question is very typical. It has been a lot of talk about the complexities, and we have seen that on the slides. Even the life cycle analysis is already a really difficult topic. So complexities in data and calculation, but it is not fairly clear what is needed to bring down the value chain emissions.
I can take that one.
Sure.
So what I would say, the first step is to look internally. There's no point already reaching out to your value chain if you haven't figured out what your priorities are in your company. So first step, look internally, develop a strategy that you're going to use to tackle sustainability as a whole. That way, your company, yourself, you know exactly where you want to be, what you want to achieve, and who needs to be part of that journey. The second step is also internally, figure out what every department needs to do. Link it to your business objectives. Link it to the senior leadership team remuneration. Make sure it's applicable, that everyone in your company wants to achieve this properly. Once you do that, then you can reach out to your value chain. Then you actually start implementing it in your contracts. You start having these talks. When you have your vendor negotiations, why is sustainability not a huge factor in there? And so implementing that phase at the very beginning, before you start developing, or even in the design phase, I would say, but before you even start doing that, figure out what you want your vendors to achieve, what you want your partners to do. Once you have that, you'll see everyone starts working a bit differently. So next contract, all of a sudden, now they're going to start looking at, oh, okay, wait, we need to measure this, we need to measure this. And they're going to start having those data sets in the procurement process too. It's also, and one thing I've noticed, it's also starting to become, I would say, a negotiation tactic on the other side that, hey, we do sustainability, come to us, which is actually great. That's exactly what we need to do, but there needs to be numbers behind that too. What are you doing as a company or as a manufacturer, as a launcher, to develop those data sets? How are you going to share them with us? In your design, when you do that, how are you going to measure that and keep us informed along the way, and vice versa? To me, and I know that everyone else has maybe, things to add, but it's really look internally, make it applicable to your company, externally, incorporate it into every business discussion that you have externally as well, and hold people accountable to the work that they say they're going to do, to the targets that they set, and also yourself, hold yourself accountable, know where you want to go, know what you need to do. And it goes back to the comment, you know, it's not just about talking the talk, it's also, you know, walk the walk, and it's going to take time, investment, and resource, and that's what I'm saying, you know, for private sector especially, you need your senior leadership teams on board, because they need to give you that investment, they need to give you those resources to be able to really tackle this head on.
Yeah, to complement that, yes, walk the walk, and I would say with my words that do your homework, do our homework, that's what we are trying to do. In Airbus, we are disclosing the scope 1 and 2 because it's mandatory by regulation, but we go beyond regulation. We try as much as we can with the scope 3 USP, but there are also ways to involve the value chain with, as I said, maybe involving other labels, other standards like carbon disclosure protocol. We are also trying to work with SBTI, Science-Based Target Initiative, to see how all this can work. That's what we in Airbus have been granted, or we've been approved recently with this at a group level. But for sure, what we want to do, as we are, let's say, the major actors in Europe for space sector, is to go together and influence also regulations, labels, and adapt those labels to our sectors. For instance, with the debris management or satellite life extension, or even with the EU taxonomy, which is not completely designed for us, but that deserves to be applicable to us as well.
We are quite flexible. We also have questions directly from the audience without Slido. Yeah, yes. Klaus-Peter Wisch.
Thank you. Does any one of you take into account the needs of all-day business later in the companies, having interfaces to accounting and steering systems like SAP or others?
Yeah, sorry. You mean take into account what you need to collect the data, or?
No, to bring it into the figures of the company.
Yes.
And there are systems like SAP or others who manage the whole process of the companies for all other figure needs. So this must be implemented there, otherwise you won't get it through.
Yeah, so 100% we do, and it's also quite a time-consuming task because there are so many solutions out there as well. And it's also about what fits best for you, your organization. How do you then translate it? How is it a manual task then at some point? You know, there's quite a few factors that need to be considered in that kind of decision and what you should take. But the software aspect of it, which I believe you're referring to, is a huge part of achieving your sustainability agenda.
And if I can complement also the systems such as SAP, of course, they are very powerful in doing life cycle assessment and eco-design, because it's basically where you can find the information also if you want to do this kind of studies. So it's definitely support.
Yeah. For instance, what we have in the non-financial reporting for the case of Airbus, it's extracted and correlated with the financial systems. All the figures, of course, there are non-quantitative information also, but it's extracted and it's correlated. But still, there's a lot of work to adapt it to our operations, our own business.
There's one more question from the audience. Please go ahead.
Yeah, I have a question because you talked about the procurement and the supply chain monitoring. So we talk about raw materials and lots of rare earth metals used in the space industry coming from poor and developing nations in the global south. So there is not only the carbon footprint of shipping, but also the human cost when it comes to mining, human trafficking. So if you have insights on clauses for extended contractor responsibility, especially if it goes for subcontracting layers, which would be very hard to trace. My other very short question regarding the applications from the space industry that could help the world face the climate change issue and emission reductions, because the space industry is very high in tech, but lots of the tech is patented or either subject to certain regulations because of security and defense, especially when it comes to material sciences. material sciences, advancements that could actually help us with transport more efficiently, with energy reduction and rationalization. So could there be regulations on how the space industry could pass on and transfer their technologies for climate change impact? Thank you.
Okay, we need short answers
maybe to make it very short regarding the question of the raw materials and their local impact. That's something we tackle. I mean, we monitor our supply chain, and we are strictly regulated by laws in Europe regarding our supply chain, how we monitor the supply chain and make sure that the supply chain is not breaking the law in terms of human trafficking or blood diamonds or whatever. It's really part of our ESG process. So definitely that's something we tackle.
One thing I wanted to add, there's actually an EU directive that's about to be announced, which is called the Due Diligence Directive, which actually ensures exactly that, because and every company who falls within scope has to oblige, which means all of us here. And it's about looking down your supply chain, not just tier 1, but all the way at the bottom to ensure that these practices don't happen.
So we come, time flies. We come to the final question where you probably, some of you, all of you could answer very fast, and I think it's an important question. What can governments do to help? Must not be everybody, but I think it's in such a complex scheme. I think it's a good question.
Well, regulation for sure, and well, if we speak about public, at least at ESA, we are having this statement of a responsible space sector, which is engaging and mobilizing. So the idea is to have our contributor signatories on the same level of understanding, awareness, and pushing for awareness and yeah.
I would say 3 things. Firstly, include SME startups within, I don't want to say regulations, but they also account for large corporations' value chains as well. So it's important they give an aid, incentivize. So, actually create some sort of incentive for large organizations, all types of organizations to adopt sustainability, track their data, whether they provide financial support. And third one is training and community support too. They need to be able to train people up on exactly what sustainability means, how they can tackle it, how they create a strategy, how they work with industry, and then also provide that platform. And I think ESA are doing a fantastic job at the moment to bring the sector together to get these discussions flowing and share best practice and challenges.
Yeah, to bounce on what Sabrina is saying, what could governments do? I will definitely not say more regulations, because we have plenty of regulations in Europe, and we are way ahead, I would say, of many countries in that field. And it's a competitive advantage in a sense in terms of sustainability. So definitely not more regulations, but more awareness, more training about this issue, this impact, and also maybe more help, more incentives regarding companies which are going in the right direction regarding these topics.
Yeah,
very short comments of
space business is international, so governments also need to work together.
Yeah.
For those regulations, we need regulations because we need to move forward, but they need to be also consistent. Otherwise, it's super difficult for us to create product and be to comply.
Yeah, and I mean, I think almost everything was said. Definitely, we need to be supported, and so we need governments to help us to bring awareness. We need them to help us also to stay competitive. As I said, it's a journey, it's a transformation. So there will be some challenging moments, and we need support in these moments. We need to reinvent somewhere, sometimes our business, and so we will need support. And we also need to be well accompanied as an ecosystem. So everybody has to be in the same dynamic for it to be impactful for our business. Yeah.
Well, thank you very much. We are 2 minutes over time, but I want to make just a 1-minute summary. So we have seen that there is certainly awareness and also an idea about the responsibilities from the agency level, from the industry level, from satellite operator level. And we also have seen that it's quite a complex framework to efficiently address, space sustainability across the different space actors and the supply chain. So there's a lot of work to do. I noted down holistic. We have to engage our employers in order to tackle the challenges. It's not only carbon footprint, it's much larger. We had quite a lot of questions which were very similar, which I could not all address. So it is, we know, and it is everything which is a little bit at the beginning, and it's actually wonderful to see that you are, at least here on the European level, that you are all united in frameworks, that the European Space Agency is going forward with documents, with regulations. Not everybody knows what Scope 1, 2, 3 is, but maybe after that session, or if you announce that more. And we have a lot to do in the next decade. And I want to thank all my distinguished panel members, and in particular Ariane Group, which has taken the initiative to organize this forum and taken the leadership on that. I want to say that these are the sustainability officers. All of you have a similar title in Europe of the main industry and the European Space Agency. Please note down their names, because in the future you can address them directly. And I want to thank also the audience for all the questions. And of course we could discuss 3 more hours, but there is a next panel. And I thank you so much. Yeah?
Well, thanks a lot, Pascal, and thanks to all the speakers for this amazing panel, and for the moderation, and for putting, as usually, everything together with the summary. May I ask you also to join us for a group picture on that side, please? If you could line up there, please. And for the audience, there is no need to leave the room, because we will continue immediately with our next session.
I've got to grab that guy real quick. He's got a typo on a slide.
This next GNF session, and as you all very well know, another strong greenhouse gas, second only to carbon dioxide in its contribution to global warming, is methane. And that is exactly what this GNF session is going to focus on, the Global Methane Observing System. And it is my great pleasure to welcome on stage the moderator of this session, Dr. Barbara Ryan, Executive Director of the World Geospatial Industry Council, but most importantly, also one of our distinguished IPC co-chairs for this conference here. And thanks for moderating this session, and you will introduce the speakers.
Very good.
Thanks.
Christian, thank you
Barbara.
so much. And welcome, everyone. It's really nice to have you in the audience. So as Christian said, my name is Barbara Ryan, Executive Director, WGIC. And so on this session, I really would like to, so Global Methane Observing System, it really ties in nicely, not only with the last panel, but this morning's plenary session. So in fact, there's sometimes when I kind of feel like, you know that saying, everything's been said. but I haven't said it. And so I kind of feel like there's going to be a lot of that in this session today. But first of all, I really do want to thank GHGSat for organizing the session. I don't know if he's in the room, but Antoine Ramier did a lot of work in the background, so thank you so much for that. And then also, Jean-Francois, you are the only, GHGSat is the only commercial capability for methane observations in space right now. So you have the dubious honor, I think, of either having a big target on your back or being applauded for that effort, and you probably have both. So
we welcome it.
Thank you for putting this together. You know, I think what we're going to hear from these speakers is that this is an evolving ecosystem. And I would have to say, in kind of getting to know these folks around the table and some work that we, WGIC, did, in many ways, methane may be ahead of the game in terms of international collaboration and some of the other greenhouse gases. You know, we heard yesterday from the French DG for CNES, whether it was cooperation or competition or collaboration. Obviously, as we look around the parties at the table here, I think you're going to see elements of all of that, and that'll come out. And then I think the only other thing I want to say is that, well, let's go ahead and introduce each of the panelists, because you do represent a unique place in that ecosystem. And so just 30 seconds, your name, your organization, and what you're largely responsible for doing. So, and Freddie, I'm going to start with you.
Thanks. Thanks, Barb. So my name is Manfredi Caltagirone. I'm the head of UNEP's International Methane Emissions Observatory. UNEP is the United Nations Environment Program. And IMEO's reason for existence is to provide accurate, free, and actionable data to those who have the agency that are able to reduce emissions in the time frame that we have, that is 79 months to 2030. Starting with the energy sector, but with the ambition to expand our work to also other sources of methane, such as agriculture, so rice cultivation and livestock, as well as waste.
Thanks. Jean-Francois.
Thanks, Barb. So GHGSat is a commercial company, and we pioneered the measurement of methane emissions directly from industrial sites from space when we launched our first satellite in 2016. So we now operate about half of all of the satellites, all of the operational satellites that have any sensitivity to methane. Also the only satellites that were specifically designed and for focus on methane specifically. So.
Okay, thanks. Antoine?
Hello, thanks. So Antoine Benoit, product manager at Kairos regarding methane emission, working with all the public and private satellites at our disposal to detect and quantify methane emission. So Kairos is the leading environmental company, providing information in both the energy and environmental sectors. We are notably working with the International Methane Observatory, providing them with actionable data on methane emissions.
Thank you, Antoine.
Hi, yeah, I'm Mackenzie Huffman, Director of Strategy and Partnerships at Carbon Mapper. We are a small nonprofit that uses remote sensing from aircraft and satellites to fill data gaps in methane and CO2 emissions. And part of how we do this is we lead a public-private partnership that includes a number of partners, including NASA Jet Propulsion Laboratory and the commercial company Planet Labs, among many others, to develop and deploy satellites with the capability to detect, pinpoint, and quantify methane emissions at the scale of individual facilities, while also making all of that data publicly available through the nonprofit. So I work on connecting that to impact.
Thanks, Mackenzie. Steve, last but not least.
Yeah, Steve Hamburg, Chief Scientist of the Environmental Defense Fund, and also the Executive Manager of MethaneSat LLC. EDF is a nonprofit, 55 years old, working across the globe, focused heavily on climate change, as well as very focused on affecting impact. EDF started methane sat as a way of trying to complement what we just heard about from the other satellites in providing high precision measurements across not just target mode, but area sources, which will be, and that satellite will be launching in early next year.
Thanks, Steve. You know, I think IAF has done a really nice job putting composition of mixed panels together, but I'm really excited about this one because whether it's UNEP and IMEO or the commercial sector or not-for-profits, two commercial sector companies, it's a great way to build the ecosystem. The only other thing I want to say before we get started, and we're going to split the whole session up into 3 segments. Some background information, why is methane even important, the technological piece of it, and then hopefully a good amount of time at the end to talk about the way forward and challenges and opportunities. But for many of you, you know that I spent most of my career, 40 plus years, in the public sector, and then came in to lead this not-for-profit organization. And when we get, you had to be a commercial sector company to join WGAC. What I knew is that through the Committee on Earth Observation Satellites, all the major space agencies, public space agencies around the world, had put a phenomenal database together, a MIM database, Missions, Instruments, and Measurements. I come into the not-for-profit or the commercial sector and said, well, where's the analog on the commercial side? Of course, at the time, we know of one now. It's not necessarily open, but we said, where is it? And so we took a baby step on just the 3 major greenhouse gases that are recognized by the convention, methane, carbon dioxide, and nitrous oxide. Worked with CS, said, here's what the public sector is doing. We compiled the data, and here's what the private sector is doing. And then what emerged was it wasn't just the commercial sector, it was also philanthropies or hybrid missions that were either partnerships, public-private partnerships, or new entities like yours that would come to the table. And yet I don't think many people actually understand the full complexity of this ecosystem and that there are really some unique players in methane observations. And I think there are some wonderful lessons here that could be expanded. And so that's why I'm excited to be here. We took that message to Glasgow, to Sharm el-Sheikh. We'll take it again to Dubai. Governments, parties around the table. Those are governments in these international mechanisms. You've got to continue to invest in your public space agencies or Earth observation agencies. They were here 20 years ago or 50 years ago. We hope they're here 20 or 50 years. But the commercial sector and other parties are coming to the table, increased spatial, spectral, or temporal resolution. And if you parties aren't either putting policies in place for public-private partnerships or mechanisms, like a couple of the last panels have said, for access to other kind of data sources, then you're really sub-optimizing your climate action. So for me, that's all about this. So background, technology, and climate action. I'd just offer anybody to weigh in on any point, but Steve, we're going to turn to you. Methane 101. Why is it important? Where is it? You know, who's doing, you know, where is it on the landscape?
So as we think about methane, as has been mentioned, we have multiple greenhouse gases. But methane is, of course, each one of them is unique. So methane is 120 times more powerful as a greenhouse gas than CO2. Now that's not a number you usually hear, because you usually hear it over a period of time. So that's kilogram for kilogram. And over 20 years, because methane is a short-lived greenhouse gas, it's more than 80 times more powerful than CO2 over the first 20 years after its release. And it's roughly 25 times more over 100 years. But this time dimension really matters. Before I go to that, so methane is responsible currently for roughly 30% of the warming we're currently experiencing. And as we think about how we're going to address the climate problem, we really have to remember we have 2 climate problems. We have the near-term problem, which is driving the rate of warming. How much will it warm over the next few decades? And at what rate will that increase? And what's the long-term total amount of warming? We tend to simplify it as the second problem, but in fact, both really matter for damages. And if we're going to solve the first problem, it's overwhelmingly dominated by methane. So if we want to reduce the rate of warming in the near term, first and foremost, we have to reduce emissions of methane. We also have to do CO2. So this is not an or, it's an and. But it's really important to recognize these different roles they play. So where is that methane coming from? It's the largest sources are from agriculture, but of course it varies from country to country. So this isn't uniform, that's a global average. And fossil fuels is the second, dominated by oil and gas, but of course coal is also important. And then we have waste. So we have those are the dominant sources, but we have to remember that it does vary across space and time. So it's not going to be the same order depending on where we go. What are the distribution of those emissions? What do I mean is, are there just a few large sources? Are there many small sources? And the answer is yes, both. So we have to think about, there's been some recent work, and I'm sure we'll hear about some of the work that Kairos is doing on ultra emitters. So these very large sources, really important, but they're almost literally the tip of the iceberg, maybe 10% of the problem. We also hear about super emitters, which we hear particularly from oil and gas, but other sources. They're also important, but they vary over spatially how important they are. And we're currently working out, because it varies from place to place. In a lot of places, the dominant is smaller emission sources. In some cases, it's the larger super emitters. So what we have to do is be able to create, and we'll talk about that, multiple abilities to measure large point sources, diffuse sources, if we're going to get the whole picture. And really what we have to do is answer three questions. Where are the emissions? How much is being emitted? And how those emissions are changing over time. And to do that, we need to be able to know the total emissions, like to call the denominator problem. Okay. How much is being emitted over how much? So what's that particular place relative to the total? And then we can understand how much is there, how it compares in different geographies, and how are we changing it over time. And to do that, we need to think about how to make those measurements. And we'll hear about those different technologies. We really basically can think about it as two different processes, one of quantifying what's going on and doing that on a global basis. We have not done that for any greenhouse gas empirically up till now, and methane is poised to do that far better than CO2 at this point in time. And then we also need very fine-grained data to be able to take action. We need both kinds of data to affect the changes that we're looking for. With that, I'll turn it back to my colleagues and to get into the meat of how we're going to do that.
All right, thanks. Great summary. First of all, I'll let anybody else that wants to add to anything he said on the methane 101 issue. And I would like to remind the audience that if you've got any questions, use Slido. That should be up and running for this session. Although all of a sudden I've lost the screen. So use Slido. Any other comments on Methane 101 from anywhere around the table? Okay, let's go into the second part then, which is the technological piece. And Mackenzie, I think you're going to kick that off for us.
Yeah, so I'll try to kick it off and then I'll hand it over to Anton. So, what's really exciting about where we are today from a technology perspective is that the stage is full, and it's full of so many diverse actors that are really utilizing what we have from a technological and an initiative perspective to focus on methane measurements and monitoring from space, which was not necessarily the case, 10 years ago. And really where we are today is built on the foundation of work from a lot of the scientific researchers and collaborations with international space agencies to develop the capabilities of the technologies that have been improved upon and deployed to be able to enable quantification and monitoring. And a lot of the last decade had been focused on kind of the development of these sensors with this capability to detect and quantify emissions at the scale of action that we were talking about. And so we're now at this unique point where those technologies are online, or coming online. And that is really exciting, and this panel is a great example of the best examples of those who are actively working to now use those technologies to drive climate action. But what we really know, and what Dr. Hamburg was really getting at, is that there's no one technology that can tackle every part of the methane challenge. There's no silver bullet, and so we need to remember that when we think about kind of the ecosystem of what we're looking at. And a lot of these different technologies are optimized to address different parts of this problem, like Dr. Hamburg mentioned. There's diffuse area sources and then large point sources. And these different capabilities of the technology that Antoine's going to talk about, can really help to support a lot of different uses. So some types of monitoring are really geared to support aggregate accounting and inventory and policy development around emissions. So thinking about regional and national scales. And others are really optimized to support direct mitigation, guidance at local and facility scale. Because at the end of the day, there's going to be people on the ground. There's waste managers, operators, municipalities, farmers, who actually need to implement the solutions, and they need the data to do that. And then there's some that can do little bits of both, so that's really exciting. But to address both of these types of monitoring, you really do need this portfolio of technologies and approaches. And that's not just satellites, so we got to give a shout out to the ground-based and airborne systems that are also a part of helping us to understand where the emissions are coming from and how to tackle them. And so I just wanted to note that. But even though we have this kind of emerging ecosystem of technologies and actors, there's still a number of gaps that remain. And in particular, there's trust in the data. So it's not completely trusted yet. There's a lot of validation verification efforts that are underway. Capacity to understand the data. So I know we'll get into this, but really helping to build the technical capacity of those that are going to use it and need it to drive action. And then resources to kind of scale the systems that we are building today to be able to offer the frequency of monitoring and measurement that we need to make sure that not only we're catching the emissions and tackling them, but keeping them mitigated, because that's also its own journey. And so this is really a big part of why we led a public-private partnership to bring some of this technology innovation and really work to scale it. Because one of the biggest issues is really making sure that this data is accessible, actionable, and understandable. But this is just kind of a piece. So I'll turn it over to Antoine to talk a little bit about the landscape of missions focused on methane monitoring.
Thanks a lot. Yeah, so I just want to set up a little bit the context about observing methane from space. So it really started 15 years ago with the GOSAT mission from JAXA. And for the first time, researchers were able to quantify the total methane emission globally. And this was a major breakthrough because we were able to compare bottom-up inventory using notably methane intensity to real measurement coming from satellite. Then, 5 years ago, the mission from the European Space Agency, Sentinel-5P, came in, and it gave us the ability not to look only at total emission globally, but at total methane emission at the regional level. And so researchers were able to estimate total methane emission in a region, for instance, in the Permian Basin, and we observed, for instance, that there were huge discrepancies between what was reported by companies and what we observed with satellite. Sentinel-5P was also able to detect ultra-emitters. So this was, what is ultra-emitters? Ultra-emitters is a source that emit more than 10 tons per hour. And we estimate that ultra-emitters represent around 10% of the methane emission of the oil and gas sector. So this is really important. And just to give you an example, at Kairos, we are monitoring more than 1,000 ultra-emitter events per year. And in terms of CO2 equivalent, it represents the emission of 20 million cars yearly, just on 1,000 of events. So this links to what Stephen was saying about the different type of sources. So this, what we call area flux mappers, so for instance, GOSAT and Sentinel-5P are very interesting to understand what are the global and regional emissions. Yet, with their core spatial resolution, we are not able to provide facility-level attribution and to attribute methane emission to specific facility. So in parallel to this area flux mapper, space agency and commercial company develop what is called point source imagers. And the big difference between point source imager and area flux mapper is that point source imager can attribute methane emission to a specific facility with a lower detection threshold. So it started in 2015 with the Hyperion mission. Then it was quickly followed by GHGSat in 2016. And now there are plenty of missions that are coexisting. So both on the multispectral side, so we have, for instance, just to quote a few, we have Landsat 8 and 9 from NASA. We have Sentinel-2 from the European Space Agency. We have also commercial missions like Worldview 3. We have also hyperspectral sensor, to name a few, Prisma from Italian Space Agency, and MAP from DLR, EMIT. And so you have to understand that all these technologies are complementary, and that today we have the technology is already here to act and to mitigate methane emissions. So for instance, at Kairos, we are providing Sentinel-5P detection and Sentinel-2 detection to IMEO so that they can notify government and operators so that they can act on methane emission. Yet, in the coming 2 years, a lot of new missions will come out, so both on the area flux mapper. So we will have the new Sentinel-5 mission, the new GOSAT mission, we will have CO2M, and on point source imagers. So a lot of the new actors are represented here. So GSGSat will be expanding its constellation. Carbon Mapper will be launching its constellation. MethaneSat will be launching its satellite, both doing point source imaging and area flux mapping. And this technology will help to accelerate, to mitigate methane emission, and this will be complementary to what is existing. So just, I guess, a final word, we have to understand that the more satellite, the more operating satellite there are, the more we can mitigate methane emission.
Okay, great, thanks. Antoine, yeah, Steve, go right ahead.
Well, I just want to add one thing to your great summary, is to remember that many of the satellites, so the Sentinel-5P Tropomi is giving you concentration data, just like GOSAT is. And that's not directly translatable into flux. So one of the challenges we have with a lot of the data currently is that it's not policy relevant, and it requires very sophisticated handling, which currently is not automated, and which means we're not able to use most of the data effectively. That's the key change we need to see. We're starting to see that, but that will be the critical change so that the data will be out in flux data product. How much is being emitted? Where is it being emitted?
Yeah.
Any other comments on the technology side? Maybe just a couple tweaks. You mentioned Landsat, did you say?
Yeah.
Yeah. So my old USGS hat, joint NASA USGS program, not just NASA,
Exactly.
although they had lion's share in building and launching the satellite. And then, Steve, the only thing I think, and it may come up into the discussion, is that even when they are just concentrations versus flux, there probably are going to be people that say, well, we just can't make a blanket statement that it's not policy relevant. Because again, it might be in certain contexts that some of that information
I want to push back a little bit on that.
Let's do that at the discussion,
fine.
because I do think that will come up in maybe a challenges piece too. And I think both Antoine and Kenzie kind of set the stage with the complexity of the partners and the ecosystem that we live in, differences of opinion on that. So, Manfredi, let's go to you first on challenges, opportunities, I don't know, policy challenges, regulatory, technical, capacity building, anything you want to comment.
And all of the above.
Just for the audience, we're not all of the above. And so we're now switching into the third and final section of this talk, which is the way forward.
Yeah.
And hope.
So Antoine made an example of way in which we're using satellite data to drive change on the ground. And then everyone knows here, satellite observation per se doesn't reduce emissions. We need to give this data in the hand, as Kenzie also mentioned, of those who really have the ability to make change. And in the oil and gas sector, it's simpler currently than in other sectors. And so for the oil and gas sector, we provide information to the asset managers, the operators on the ground, and as well as the government in which jurisdictions these assets are located. This is part of a program that UNEP launched at COP27 together with the IEA and the Climate and Cleaner Coalition, and in support of the objectives of the Global Methane Pledge that, as you might know, is an international effort subscribed now by 150 countries, in which those countries commit to collectively reduce emissions at least 30% between now and 2030. That is the is the floor of what we need to do according to the IPCC to keep the 1.5 temperature increase alive, as is said. And so through the Methane Alert and Response System, we use a variety of satellites just to confirm the fact that no single satellite can give us all the answers. But through this combination of satellites, we then provide information again to the operators, and we're starting to see some actions. In some cases, the operators are aware of the emissions that they're having, but those might require some more capital-intensive intervention that needs more planning. But in some other cases, they have not realized that a tank the tank top has been left open, or a flare is unlit, or a valve is not tight as it should. And we're seeing example of mitigation as a result of the notification that we're providing. This is just a start. It only covers the tip of the iceberg, as Steve was mentioning, but is an initial step that is necessary also to build the confidence to the larger community of the opportunities that this satellite observation represent, if combined with, as Kenzie was mentioning, to other less top-down system. Now, the objective obviously is to reduce emission, in particular from the oil and gas sector, dramatically between now and 2030. We know enough to act. We know that companies and governments should take action. But what we believe is that, as UNEP, is that this global data set of empirically verified methane emissions will be really able to provide different actors with the information they need to better target their action. So if they are consuming countries, to prioritize import from countries that have lower emissions associated with the production and transportation of fuels. In case of producing countries, to better target regulation or actions but also for the civil society and the general public to hold the system accountable. And so we believe that there is an important element that is related to transparency. There is now talks about radical transparency on climate action, and this is absolutely where we need to get, to give the information to those who can act on it, but to provide the information also to the general public so that we can reward concrete actions, and we can the alternative to reward that is not punish, but lack of actions, right? I was trying to look for a more diplomatic word that I didn't find, but hopefully you won't hold me accountable for that. Right. I'll leave it here to start.
All right, Manfredi, thanks. You know what? We'll drill down into that a little bit more, because whether it's back to the in situ point measurements that Kenzie talked about, or maybe even some of the database, I understand the U.S. has got or will have a greenhouse gas information system, just U.S. agencies, as I understand it, NASA, NOAA, and EPA, emerging effort. Maybe there are other examples around the world as well.
And if I can say, that is great, right? So we absolutely need the most advanced countries and economies to take a leadership role on this topic. But we also need to make sure that everyone else in the world has access to this information, and as you were saying, knows how to use this information. So we're working with a number of actors, those around this stage, but also academic institutions, not only to engage them on the monitoring, but also on the capacity building, on being able to make products that folks on the ground are able to use with confidence. And frankly speaking, there is a risk of all this flux of information that will come down from space, but from other methodologies and from other approaches. And there is the risk of this confusing more than is going to help. So what we really need is to make sure that everyone has the confidence that the information that are provided are accurate, and as I was saying, they're free and that are actionable in the time frame we have to reduce the climate crisis.
Jean-François, thanks. I think that's a good segue over to you on a couple different points. One, the accuracy issue. I understand you've now gotten third-party status as an ESA mission. I understand the protocols and rigor associated with that are pretty intense. But also maybe on the action side, when I hear you talk, I hear a lot of passion, and I guess I automatically think of Geneva and Voltaire, that the perfect is the enemy of the good. So you want to talk a little bit about action on that particular?
Yeah, well, our approach is obviously a little bit different, right? Like, we're a commercial company. So in order for us to survive and continue launching more satellites, so we can do some of the things that were talked about today, like monitoring emissions more persistently so we can figure out, are they intermittent? Are they always on? Which ones should be prioritized to be fixed? So in order to be able to do that, we have to launch more satellites. To launch more satellites, we have to generate revenue. So, you know, we talked about the policy making, and that's very important. Policy making eventually drives change. Advocacy usually drives change as well on the longer term. We take a slightly different approach where we work with industry to get them to address the emissions. I mean, in a lot of cases, you know, you look at the oil and gas industry, for example, these leaks will be addressed by the operators. By and large, they have to put boots on the ground, walk to the site, and go fix what has been identified. So I would perhaps push back a little bit on what Steve mentioned earlier, that measuring concentrations was not appropriate. It might not be appropriate for advocacy and policy making, but measuring concentration and converting it to an actual flux has proven to be actually quite accurate through blind testing. But more importantly, it's proven to be very effective in working with companies and showing them where to take action and how to prioritize, because you can give them a scale as to which emission should be addressed, and also identify exactly where, which actual piece of equipment would benefit from that. So, that's what we focus on. We focus on engaging industry, providing them with that data. We have the largest database of point source emissions by far. Not all of them are readily addressable. Some landfills and some dump sites around the world are very difficult to address. Coal mining, especially open pit coal mining, remains a very nebulous thing to address. Underground mining is much easier because you can actually capture the methane. Technology exists. To do that, it's not necessarily easy, it's costly, but the mechanisms exist. So we have many examples of working directly with industry to do that, and we've actually even published examples of that. One of them was a white paper we published a few months ago with our partners at OGCI and also Carbon Limits that are based here in Oslo, where we did something that had been thought to be, maybe not impossible, but something that was thought to be very difficult, is to engage local oil companies in countries like Iraq. Like, this particular project was in Iraq, and it was on a small scale, but we managed through an outreach and showing them some opportunities for them to achieve reductions, that it was actually possible to first engage them successfully in a productive manner, get the leaks fixed, but more importantly, start that discussion that Manfredi was talking about in terms of educating, creating a culture that not just fixes the leaks, but also works to prevent them from happening in the first place. So proper maintenance of equipment, those kinds of things. So that's what that project was about. That's the bit that Carbon Limits was doing. And we're now scaling that to many other countries. And again, it's a small scale, it's a starting point, but it plays a role into this whole ecosystem of reducing emissions that we're talking about. So, you know, when we look at, Manfredi mentioned the Global Methane Pledge. Okay, we're looking at 2 years ago now at Glasgow in COP26, and that's by 2030. And now we're, 7 years away from 2030, and we have little to show for. So this is coming up really fast, and the point is that's a 30% reduction by 2030. We don't have to address everything. We're working on things like rice paddies, like dump sites that are difficult to address, melting permafrost, all these different things that are difficult to address but need to be looked at. But to get to that first 30%, we can work with industry, we can work with operators around the world to actually achieve that, and at the same time all pull in the same direction to do that. So that's perhaps a different look on things, but that's our approach.
I want to give everybody an opportunity to talk about kind of this last piece about way forward and challenges and opportunities, but there are two questions that from the audience that I think kind of pertain to what you're saying. One, how do you plan on building trust within the industry, as some may question or even challenge data from observations, even supported by NGOs, not just the commercial sector, but essentially non-government is what I'm hearing here. I mean, they trust the public sector agencies, maybe not so much on the philanthropic or NGOs or commercial sector. And then also, what about work with the national security sector? So if you could touch on those 2 points, and then we'll open it up.
I could touch on them very briefly so that others can have a chance to also chime in. But in terms of building trust, first of all, there's no one-size-fits-all approach. There are geopolitical considerations that are really important to take into account. But I would contend that the lack of trust isn't just like the problem that we're facing today is that it's not a lack of trust in commercial versus NGO or public sector. It's a lack of trust in satellites. And that's alarming, frankly, because the data is proven, not just our mission, like all missions that have been flying that Antoine mentioned for years, that data support speaks for itself, and you can cross-correlate between platforms. And that's something that we do. We collaborate together with IMEO, for example, to kind of combine the different data sets, show to certain countries that this is that can be trusted. So there's a need for advocacy. There's a need for also for this kind of data to be shown to these operators. But there's also the reality that sometimes when we advocate in the media, for example, some of these actors that we're counting on to make a difference are getting their backs up, and they're taking a step back and saying, okay, this is not something I want to work with, and that's not necessarily always productive. So there's a balance, like we're all walking a certain high wire act where, in Europe, in North America, revealing some things about companies can be really, can push them to take action. In other countries, it's not effective at all. They might just start dismissing it completely, and will take longer for them to actually use the data that can be acted on today. So that would be the point that I would make for that.
All right, thanks. National security sector, real quick.
The national security sector is kind of related to all of this. I mean, there's an interest in understanding the global footprint of emissions, and I think you see the same sort of questions and concerns, and the data that satellites provide is equally useful to them. So.
Okay. Steve, I think you had your hand up, and then Kenzie.
Yep. I just want to clarify something. I think we're in radical agreement here. Okay. So my comment about the concentrations isn't that you don't need them, they're not sufficient.
Yeah.
So that's where Kairos and what Antoine's work has really been so powerful is developing the software to take the Tropomi data and convert it into policy-relevant flux data. So it's not that you don't need concentrations, it's just most of the missions stop at concentrations, and you have to take those extra steps. So that's the key there. So I think we're all saying the same thing, but it's important to remember that when a mission puts it out as concentrations, that itself is not actionable. Is useful for science, but it's not actionable. You have to take the next step. Yeah. And I just want to add one other thing to Mackenzie's point. There are many tools out there to look at methane, which is wonderful. We've got, as you said, aircraft and drones and car-based. But the bottom line is, for the overwhelming majority of the globe, we only have space-based data. So we don't have access. So the point is that we're blind in much of the world. And what we need to do to have, as Manfredi said, radical transparency, we really need to have global data of equal quality that's demonstrated. And then the last point I'd make is that there is a growing effort to do coordinated reference, controlled release experiments, testing, which everybody can see. It's totally transparent. And I'm fairly optimistic that we're seeing a lot of agreement and alignment because of these kinds of efforts, that there is a growing confidence in the space base because there's truly independent testing, validation. You don't have to trust anyone, you can look at the independent data.
Yeah, okay. I don't want to belabor the point but I will. And that's the only red flag, or the hairs on the back of my neck, went up when we said that it might not be policy relevant, because some out in the science community will argue that the science they're doing, maybe there's a long lead time, but it will in fact be policy relevant at some point.
Eventually.
So, yes,
but there's an important distinction between that, because we need action now. And I'm a scientist and I use a lot of data, but you can't, one of the things most people don't understand is you take that concentration map, and just because there's more here and less there does not translate to where the sources are.
Yeah, no, okay, Kenzie, let's go to you.
Or do you want to respond?
No, please go on. I will.
No, I was just going to second a lot of that. You know, in terms of needing this, we're blind in a lot of places, and that is what's so amazing about satellites and the capabilities that they're bringing to this equation. And that is where scaling these technologies and getting more, I always say more eyes in the sky, we need it. And so getting it at that granularity and building towards kind of this global monitoring system that brings together a lot of this transparency and helps support accountability, but also engagement with those who would prefer a little more of a private touch. And I think that is really critical, and why partnerships and why nonprofits and why commercial sector is all really integral to solving this problem together. The other thing is, you know, on the lack of trust in the industry, but also with satellites, I think that was spot on. And it is a lot of kind of how can we help to better support, you know, the frameworks and the validation efforts, just trust that those are built. And this actually came up in the science comms section yesterday, which is even though the science and the data is clear, talking about it, making it clear, building that trust outside of the science community is also really, really critical. And I think that's where governments can really step in. They can do a lot to help to help reinforce that these measurements are accurate and they have a lot of science behind them, and also support frameworks or places that actually can enable the type of testing that we need to just show that and prove that. And so there's a lot of stuff underway in the US. For example, there's METEC, which is in Colorado, that actually does that for ground-based and airborne sources, and they're looking at satellites. So there's a lot of those types of things that governments can really do to help enable the trust in the data and the science in a way that reinforces that we already know that it is actually, you know, solid.
Yeah. Thanks, Kathy. Antoine.
Yeah, thanks. So I just wanted to add on what Steve was saying. So yeah, independent experiments are already here. Some has been conducted, and the results are here to prove that we can use satellite data. Other will be done with upcoming satellite data. And so we can't attack satellite by saying it's not precise, because we have this independent experiment proving that, yes, it's precise. On the drive climate action, what you were saying, Jean-François and Manfredi, I wanted to add that first, we need also to increase public awareness, because methane is not a subject that everyone can address. And for that, we need, in my opinion, we need to work with journalists so that the subject is taken serious. So for instance, at Kairos, we are working with Bloomberg News. We are trying to provide data to other journalists to be sure that the methane problem is understood by the whole space community, but also by the general public. So this is the first part. Second part is that also we need regulation, because, GLOC is saying they are working with operators, but to be sure that operators are tackling this problem, there need to be regulation. So in the US, there is the Inflation Reduction Act that should lead to a real plan for methane emission next year. In the European Union, there is this new law that was voted by the European Parliament 2 weeks ago, that needs to be voted by the Council, so that we have a law that regulates imported methane. And with all this legal framework, operator will be constrained to work on this and to tackle this problem.
Okay, Manfredi.
Thank you, Barbara. Two points. One on the control release, then the testing. IMEO is trying to help on this front. We're expanding the work that some academics have done in the US. There has been recently an agreement between METEC and a European equivalent of METEC that was announced. We're hoping to be able to expand these also to other jurisdictions. For example, in Asia, we're planning as IMEO a big control release engagement for beginning of 2024. which will be inviting technology providers from, as you said, not only from satellites, but also drone and aerial and potentially ground-based monitoring system to try to test and understand in which condition they work best and how they can be combined together to achieve results. That is what we want, that is the reduction. And then on the trust issue, I think we need to, so UNEP, let me back up a second. UNEP runs an initiative that is called Oil and Gas Mineral Partnership 2.0 that currently covers around 40% of global oil and gas production, has 120 oil and gas companies, and you can imagine an oil and gas company is not the usual fellow of the United Nations Environment Program, and indeed there was a little bit of convincing to be done to get the leadership of on both sides, on the company side, but also on the UN side, to say, well, this is too big of a prize to not work together. And what we're getting through this partnership is asset level data that are empirically measured by the companies and then reported at asset level to UNEP in a way in which we can corroborate the emissions with other sources of data, be them from planes, realizing that there are constraints in certain jurisdictions to fly a plane, and indeed increasingly from satellite. And this is, I think, a key element is the need to get our neck out there and take risks. The objective here is, again, to reduce emissions, and if to do that we need to, again, engage with unlikely fellows, so be it, right? And so this is an example. There are clearly others, but I think it's something that is pretty powerful in also in building trust, in showing industrial partners that we are ready to give them credibility in exchange for action, and so more of these examples, I think, should be brought up.
So I wanted to add to Antoine's point about regulations driving action, and it's entirely true. So regulations do that. Regulations are crucial, and in some places, regulations have shown to be really effective. So from Canada has demonstrated that over time the regulations can make a difference. And there's still a long way to go. There's still a lot of progress to be made, but at the same time, the situation is shown improvements. So, however, there's other drivers that can compel, that can drive emissions reductions. And the challenge with regulations is that they take a long time to come to fruition. And sometimes they take even longer to see the full effect. So you still obviously need to work on them and get them put in place. But you use the EPA regulation that's being discussed in the U.S. for over almost a year and a half now. That will be released soon. It'll be released just in time for a new election cycle. It will be held up in courts. It might be scrapped or canceled, and then the cycle will repeat itself. And so, there's going to be a need for reinforcement and pushing for these to be put in place. In the meantime, there's other factors that I was just alluding to that can compel people to change their behaviors. One of them is the pressure from investors. The investment community, shareholders are putting pressure on industry to reduce their emissions and show the progress. So even in the absence of regulations, there's already evidence that some operators, some companies don't really have a choice. They have to do that. They have to. The other factor that compels it is, frankly, for the oil and gas industry specifically, if they're leaking methane, they're leaking product. So the realization that you keep that molecule in the pipe and you can actually sell it, or so you're saving the environment at the same time. So I guess the end goal that we're all seeking is happening, but the actual initial driver might be a little bit different. But in the end, should we really care? I would argue that probably not. I mean, right now we're after that first 30% for the global methane pledge, but over time, regulations will drive everything, absolutely.
I was also, let's go ahead. Let me hear from you guys.
So I just want to completely agree with it, and I think coming back to the point that Mackenzie made, it's an all of the above. So we're not talking about there's one magic bullet here. We need to have multiple mechanisms. And I would just say one thing in the US we just need to remember is, yes, there are regulations, I mean, maybe a little more optimistic, but there's also law. So it's not just regulations. So there's a methane fee that was put in law by the Congress last year. So that's important to remember. But we do need to remember it's all of the above, and that we can also need to remember that it's not just oil and gas. Oil and gas is a low-hanging fruit. But we are also seeing commitments like Danone, who's saying on the ag side, we're seeing countries working in, we were partnering with New Zealand on the ag side. So we have to remember that there are multiple sectors. Oil and gas is very important, but not sufficient. And IMEO, I'll put the plug in for IMEO, is going to be working across all the sectors and appropriately. The other thing that's really important is the controlled releases are not just, so we're doing currently single blind, they're going to be doing double blind. Happy to explain to anyone the difference, but this is important. As we get more sophisticated and better, people are going to have even more confidence because we're going to get better and better independent validations and the system that Manfredi mentioned at very multiple geographies. This is all of the kind of coming together, and we need to really recognize, and that within the next year, we're going to see a radical change in the quantity of data that will be available. We'll have a comprehensive map of North American oil and gas methane emissions by the end of the year. We're going to see it in the end of next year across the globe.
Yeah, no, thanks. I'm sorry, did you guys raise your hand?
I think Freddie raised it.
Oh, yeah, sorry.
I mean, just to build on what Steve was mentioning and Jean-Francois was mentioning, we're talking about difficulties on using regulatory regimes in two of the countries that probably have the highest institutional capacity in the world, and we need to make sure that we take a global approach here. More than 50% of oil and gas production, looking at oil and gas, but it's the same is for agriculture and for waste, is coming from the south of the world. And so how do we put in place systems that allow them to work effectively to reduce emission? And how do we create the right incentive and the right support for them to take on this challenge? Because it won't be enough to fix the problem in Canada, in the US, or Europe. We need to really take a global approach.
Thanks for that. You guys, for a couple of the questions that I didn't get to on here, please reach out to the individual speakers because some are ag-related, some are still really back to the communications piece and the kind of the boring part about talking about standardization. I think a great question to end on for everyone, and again, just 30 seconds each. What are the realistic outcomes of your work in 20 years? Realistic outcomes of your work in 20 years. So what will it look like, Steve?
We're going to slow the rate of warming dramatically as a function of methane emissions reductions. We've seen, despite the slow progress we described, we've seen a radical change in the awareness and the focus. There's not pushback on the importance of methane anymore. Now we got to get it done. In the next couple of years, we're going to see space-based capacity growing exponentially, and we're going to see, I think, quite dramatic reductions. I am an optimist because I've seen so much change in the last decade, but we have a lot of hard work to do, and that will change the rate of warming in my lifetime.
Thanks, Steve. Kenzie?
Yeah, no, everything Steve said, that is exactly right. I think we're going to achieve some reductions. I think the other big thing is we're going to have an entire group and generation of scientists and people on the ground who understand satellites and the use and capabilities and how all of this data integrates that are so much more capable than what we have today, because we're at the forefront of connecting those dots. And I also think we're going to be, expanding into really interesting new types of technologies that can give us more precision and much more visibility and have, as I said, more eyes in the sky that's actually going to get us the data on a real-time basis globally at the coverage and the frequency that we need to maintain all of this wonderful work that everybody's doing.
Thanks, Antoine.
Thanks. Yeah, so two things just to comment on what Steve said. So methane lifetime is around 12 years. So in 20 years, if we start now to decrease, we will see real impact on global warming very soon. So this is the first thing. Second thing is about the way we will have more people working on this sector, because regulation will introduce methane fees like in the US. This will bring a lot of money to the sector, and we will have more and more people and more technology up there to work on this. So I'm pretty optimistic on this side, as Steve, but I think it will make a major impact.
Somebody in the audience will be quite happy with that response, because there was a question about funding, and is it always going to be on the public sector side?
I'm happy to take the question after the session.
All right. Jean-François.
Well, I think we'd have issues if we didn't all violently agree with what Steve said. So yeah, everything that Steve said, achieving reductions, but I'll deviate from your rule to say a realistic outcome in 20 years. And if I have to dream a little bit, in 20 years, if we can be out of business because there's fewer point sources to measure, and people operators and companies around the world are actually using responsible practices to not just mitigate but prevent before it happens, then it will be, that would be the dream scenario. Of course, there's still a need to monitor. There's still a need to keep an eye. You don't take the battery out of your smoke detector because there hasn't been a fire in your house for 6 months. So you still need to take a look. But we've talked about the full body of work of eyes in the sky, and that will continue, of course. So we'll make sure that the progress continues.
Manfredi.
So reductions in 20 years, and as building on some the others have said, getting a better understanding of why emissions are coming from in the first place. So there is this assumption that emissions are somehow stochastics. They happen because they happen, and we should prove this hypothesis and check whether it's true. And my intuition is that we think this way because we don't know enough, because we have not paid enough attention to the methane problem until very recently. And all these efforts will be helping in getting a better understanding of why emissions come from in the first place, so that we can take, as Jean-François was saying, actions before the emissions get emitted in the first place. Thank you.
You guys, there are just 2 points that I said I wanted to come back to, and then we'll wrap this up. And it really was the in situ, or Kenzie, that you said, because that report that we put together on a mapping of methane emissions, public, private, and hybrid, that was done in partnership with Al Gore's group, Climate Trace, and GEO, the group on Earth observations. And GEO is fond of saying about Earth observations, it's not just space-based observations, it's any observations in, on, or around the Earth. And then I'm also reminded of the Nairobi Conference of the Parties. So somebody mentioned it was at COP15. So how many years ago, right? Yeah. CIAS put a report together and said, while in situ measurements will remain essential because they measure what we can't measure from space, that Earth observation satellites are the only realistic means to collect the global data that we need to tackle climate change. So that was COP15. We're already on COP28. We've got to somehow continue to keep some pressure and urgency on this issue. Thank you, everybody, for the urgency that you're bringing and the collaboration and cooperation. And thanks to the audience for hanging in with us for a couple minutes too late.
Thanks a lot. Thanks a lot, Barbara, for the moderation, and a big thanks to all the speakers. Please, can we have also a group picture with you on that side? If you line up in the front, maybe. Take these off? No, you can take it off afterwards. And we will break now for lunch. Lunch will be served in the brasserie, and this lunch is sponsored by Planet. I would like to ask everybody and invite you to be back here at 13:50, so 10 to 2, please. We will continue. Thank you.